Space is often imagined as this vast, uncharted frontier where every discovery is the result of meticulous planning and years of scientific calculation. But what if the truth is far more thrilling? Picture this. Some of the most jaw-dropping revelations in astronomy weren't the product of careful strategy. They were pure, unplanned accidents. A scientist tuning a radio telescope picks up a strange, repeating signal from deep space. A team studying distant stars suddenly notices an odd wobble, revealing a hidden planet. These aren't just lucky breaks, they're moments that shattered our understanding of the cosmos, rewriting textbooks and leaving even the most seasoned astronomers in awe. Think about it, the universe loves a good surprise. For every discovery made with precision, there's another that came out of nowhere, a cosmic curveball that changed everything. These accidental finds aren't just footnotes in history, they're proof that curiosity, combined with a dash of serendipity, can unlock secrets we never even knew to look for. And that's what makes them so extraordinary. They remind us that space isn't just a cold, empty void. It's alive with mysteries waiting to trip us up, to jolt us out of our assumptions and into new realms of understanding. So today, we're diving into 50 of these incredible moments, the times when luck and wonder collided to reveal something astonishing. From bizarre radio bursts that defy explanation to planets hiding in plain sight, each of these discoveries started with a simple, "Wait, what was that?" And that's the magic of it all, because in the end, science isn't just about what we set out to find. It's about being open to the unexpected, to the sheer, delightful chaos of a universe that keeps us guessing. Ready to explore the cosmic accidents that changed everything? Let's begin. In 1965, two astronomers named Arno Penzias and Robert Wilson were just trying to do their jobs. They were working with a massive radio antenna in New Jersey, fussing over an annoying hiss of static that just wouldn't go away. No matter what they tried adjusting the equipment, cleaning out pigeon nests, even shooing away the birds themselves, the noise persisted. It was faint but unmistakable, a steady hum coming from every direction in the sky. At first, they assumed it was just interference, some earthly glitch they could fix. But the truth was far more extraordinary. That persistent static turned out to be the afterglow of the Big Bang itself, the cosmic microwave background radiation. It was the oldest light in the universe, cooled and stretched over billions of years into a faint whisper of microwaves. This accidental discovery didn't just solve a technical nuisance, it confirmed one of the most groundbreaking theories in science. The Big Bang wasn't just an idea anymore. It left fingerprints, and Penzias and Wilson had stumbled right into them. Think about how wild that is. Two scientists, just trying to troubleshoot an antenna, ended up holding a piece of the universe's birth certificate. Their work earned them a Nobel Prize, but more importantly, it rewrote our understanding of cosmic history. Suddenly, we had proof that the universe began in a fiery explosion, and that its echo still lingers all around us, hidden in plain sight. And that's the real magic here, how often the universe leaves its biggest clues in the smallest details. That faint hiss could have been dismissed as a technical error, written off as background noise. But because they kept digging, kept questioning, they uncovered something monumental. It makes you wonder what else we might be missing, what other cosmic secrets are hiding in the static of our instruments, waiting for someone to listen just a little closer. Sometimes the universe sends us signals so strange, even scientists joke about aliens. In 1967, a young researcher named Jocelyn Bell Burnell was sifting through reams of data from a radio telescope she helped build when she spotted something bizarre. a series of rapid, precise pulses arriving like clockwork from deep space. The rhythm was so unnervingly regular, so artificial feeling, that her team half-seriously labeled it LGM-1 short for Little Green Men. Could this finally be evidence of extraterrestrial intelligence? The truth was even more mind-bending. Those pulses weren't messages from aliens but the heartbeat of a cosmic lighthouse, a spinning neutron star so dense, a teaspoon of its material would weigh 1 billion tons. These objects, later named pulsars, are the remnants of massive stars that exploded in supernova, their cores crushed into ultra-compact spheres no bigger than a city. As they rotate at dizzying speeds, beams of radiation shoot from their magnetic poles, sweeping across the universe like a celestial strobe light. When those beams happen to point toward Earth, we detect them as rhythmic blips, cosmic metronomes keeping perfect time. What's astonishing is how easily this discovery could have been missed. The pulses were buried in hundreds of feet of paper printouts, faint anomalies in a sea of squiggles. But Bell Burnell's sharp eye and relentless curiosity turned a quirky blip into a paradigm-shifting revelation. Pulsars didn't just prove the existence of neutron stars. They became cosmic laboratories for testing Einstein's theories, tools for mapping the galaxy, and even natural GPS systems for future interstellar navigation. And here's the kicker, that playful Little Green Men nickname. It speaks to a deeper truth about science. Before we uncover the answers, we often stumble through the absurd, the improbable, the seemingly impossible. The universe doesn't hand us tidy explanations. It throws riddles wrapped in static, pulses masquerading as alien Morse code. But that's the thrill of the hunt. Every cosmic "what on earth is that?" moment holds the potential to rewrite the rules. So the next time astronomers whisper about signals they can't explain, remember, sometimes the reality is stranger than even our wildest guesses. For centuries, we assumed planets outside our solar system would behave just like the ones orbiting our sun, orderly, predictable, and spaced at comfortable distances. Then in 1995, 2 astronomers in Switzerland turned that assumption on its head. Mitchell Mayer and Didier Queloz were studying the subtle wobbles of stars, tiny shifts in their light caused by unseen gravitational tugs. They expected to find hints of companion stars or maybe brown dwarfs, certainly not a planet. But the data from a star called 51 Pegasi told a different story. There was a rhythmic sway in the star's motion, a telltale sign that something massive was pulling on it. But here's where things got weird. This invisible object was orbiting so close to its star that a single year there lasted just 4 Earth days. That defied everything we knew. In our solar system, gas giants like Jupiter keep a respectful distance from the Sun, taking 12 years to complete an orbit. Yet here was 51 Pegasi b, a scorching, hot Jupiter clinging to its star like a moth to a flame. The revelation sent shockwaves through astronomy. If planets could form in places we never imagined, then our cosmic neighborhood wasn't the rule, it was the exception. Suddenly, the galaxy seemed wilder, more unpredictable. Mayer and Queloz hadn't just found a planet, they'd cracked open a door to a universe teeming with possibilities. Within years, telescopes trained their sights on other stars, and the floodgates opened. Exoplanets of every kind emerged, super-Earths, water worlds, even planets with 2 suns like Tatooine from Star Wars. What's astonishing is how close we came to missing this breakthrough. Stellar wobbles had been studied for decades, but no one thought to look for something as audacious as a planet hugging its star. It took an open mind, a willingness to question the expected, to see the anomaly for what it was. And that's the beauty of accidental discovery. It doesn't just give us answers, it rewrites the questions. Now, with thousands of exoplanets catalogued, we know one thing for sure: the universe doesn't play by our rules. Planets orbit pulsars, float freely in space, or dance in patterns we're still struggling to understand. And somewhere out there, another 51 Pegasi b is waiting, another cosmic oddball poised to shatter what we think we know. The night of August 15, 1977, was supposed to be just another shift at Ohio State University's Big Ear radio telescope. Volunteers were scanning the skies for any hint of extraterrestrial signals, a routine part of the search for extraterrestrial intelligence program. Then at 10:16 p.m., the machine spat out a sequence of numbers and letters that would become legendary. The signal was so intense, so perfectly aligned with what scientists predicted an alien transmission might look like, that astronomer Jerry Amon circled it in red pen and scrawled a single word beside it: "Wow." What made this burst so extraordinary wasn't just its strength, it was its precision. Lasting exactly 72 seconds, the signal occupied a narrow frequency band near the hydrogen line, a wavelength many scientists believed advanced civilizations might use for communication. It came from the direction of the constellation Sagittarius, vanished as abruptly as it appeared, and was never detected again. Decades of follow-up observations, improved technology, and countless hours of analysis turned up nothing. No repeat signal, no natural explanation that fully fit. It was as if the universe had whispered a secret and then refused to say another word. Theories have swirled ever since. Could it have been a passing comet reflecting radio waves? Unlikely. Detailed reconstructions ruled out known comets in that region. A military satellite transmission. No records match the signal's unique profile. The most tantalizing possibility that it was a deliberate broadcast from another civilization remains unproven but impossible to dismiss. The WOW signal sits in this strange limbo, too remarkable to ignore, too fleeting to verify. Here's what makes it haunting. In a universe where most mysteries eventually yield answers, this one refuses to. It's a reminder that for all our technology, space can still hand us puzzles that leave the brightest minds stumped. That burst of static wasn't just a scientific anomaly, it was a mirror. In it, we see our own longing to not be alone in the cosmos, our hope that somewhere out there, someone might be listening too, and perhaps that's the real legacy of the WOW signal. It's not proof of aliens, but proof of how much we still don't know. Every time we point a telescope at the stars, we're not just collecting data, we're casting a line into the cosmic dark, wondering what might bite. Most of the time, we reel in empty hooks, but once, just once, something tugged back, and that's enough to keep us listening. When Voyager 1 swung past Jupiter in 1979, scientists were ready for another textbook snapshot of a frozen, pockmarked moon. Io, one of Jupiter's largest satellites, should have looked like our own moon, an ancient, silent world scarred by billions of years of impacts. But as the spacecraft's images streamed back to Earth, the team saw something impossible. Plumes of material were erupting hundreds of miles into space, staining Io's surface in vivid yellows and oranges. This wasn't a dead rock, it was a volcanic inferno, the first place beyond Earth where humans witnessed active eruptions. The discovery sent shockwaves through planetary science. Until then, volcanic activity was thought to require two things: a radioactive core or the residual heat of a planet's formation. But Io had neither. It was too small to retain that kind of internal warmth, and yet there it was, spewing lava fountains taller than Mount Everest. The answer lay in Jupiter's immense gravity. As Io orbits, the gas giants pull along with the tugs of neighboring moons Europa and Ganymede. Stretches and squeezes the moon like a ball of clay. This constant flexing generates friction, heating Io's interior to melting point. The result, a world with over 400 active volcanoes, some erupting with enough force to briefly outshine the sun in ultraviolet light. What's staggering is how easily this could have been missed. Voyager 1's primary mission was to study Jupiter itself, not its moons. The volcanic plumes were spotted by sheer luck when a navigation engineer, Linda Morabito, noticed odd umbrella-shaped features in long-exposure images. At first, she assumed they were distant moons caught in the frame. But when she checked the math, the truth hit her. Io was erupting. This accidental revelation didn't just add a new moon to the map, it rewrote the rules of planetary science. Suddenly, tidal heating became a universal force, capable of turning frozen worlds into geologic pressure cookers. Europa, another of Jupiter's moons, might hide a liquid ocean beneath its icy crust, warmed by the same gravitational kneading. Even distant exoplanets could harbor volcanic moons, their surfaces reshaped by the dance of unseen giants. And that's the real lesson of Io. The universe doesn't just defy expectations, it revels in them. For every quiet, cratered world we expect, there's a fire-breathing moon waiting to jolt us awake. So the next time we assume a distant planet or moon is just another dead rock, remember, sometimes the cosmos saves its most spectacular shows for the places we least expect. By the late 1990s, astronomers thought they had the universe figured out. The Big Bang had set everything in motion, and though the cosmos was still expanding, gravity was expected to slow it down over time, like a ball rolling uphill, gradually losing steam. Then two teams of researchers, studying the faint light of exploding stars billions of light years away, stumbled onto something that turned that assumption to dust. Instead of slowing, the universe's expansion was speeding up. It was as if that ball had suddenly been kicked downhill, racing faster with no explanation in sight. The discovery hinged on a particular type of supernova white dwarf stars that detonate with such predictable brightness. They serve as cosmic measuring sticks. By comparing how bright these explosions appeared versus how bright they should be, scientists could calculate their distance and, in turn, track how fast space had stretched since the light began its journey. But the data told a bizarre story. The most distant supernova were dimmer than expected, meaning they were farther away than the standard model predicted. The universe wasn't just expanding, it was accelerating. The implications were staggering. Something was overpowering gravity, pushing galaxies apart at ever-increasing speeds. That something earned a deliberately vague name, dark energy. It's not a substance we can see or touch, but a property of space itself, woven into the fabric of reality. Imagine blowing up a balloon with invisible ink as it inflates. New space appears out of nowhere, carrying galaxies along for the ride. Dark energy does that to the universe, stretching the cosmic canvas faster with each passing moment. Here's the kicker: dark energy makes up roughly 68% of the universe's total energy, dwarfing everything else, stars, planets, even dark matter. Yet we know almost nothing about it. Is it a constant force, or could it change over time? Could it one day tear atoms apart in a big rip? The questions outnumber the answers, and that's what makes this accidental discovery so thrilling. Think about the sheer luck involved. Those supernovae could have been overlooked as calibration errors or atmospheric interference. Instead, they revealed a universe far stranger than we'd imagined, one where empty space isn't passive, but alive with a mysterious energy we're only beginning to grasp. And that's the humbling truth dark energy teaches us. For all our theories and telescopes, the cosmos still holds cards it hasn't shown us yet. Every time we think we've got it figured out, the universe throws a curveball, and suddenly the game changes all over again. In October 2017, a telescope in Hawaii designed to spot potentially hazardous asteroids caught something far more extraordinary, a faint dot streaking across the sky at blistering speed. At first glance, it seemed like just another space rock, but as astronomers tracked its path, the numbers didn't add up. This object wasn't orbiting the sun, it was passing through, arriving from somewhere beyond our solar system. They named it Oumuamua, Hawaiian for scout, and what followed was one of the most heated cosmic mysteries of the decade. Oumuamua defied every expectation. Most comets and asteroids follow predictable orbits shaped by the sun's gravity, but this visitor had a trajectory so extreme it could only have come from interstellar space. Then there was its shape. Observations suggested it was long and thin, like a cosmic cigar tumbling end over end. Even stranger, as it raced away from the sun, it accelerated slightly, as if pushed by an unseen force. Comets do this when their ices vaporize, creating a gaseous tail. But Oumuamua showed no visible tail, no cloud of dust or gas. It was as if the universe had tossed a rock into our backyard, only for us to realize it wasn't a rock at all. Theories erupted. Could it be a shard of a shattered planet, ejected from another star system? A bizarre hydrogen iceberg sublimating invisible gas? Or, as one Harvard astrophysicist controversially suggested, an alien light sail propelled by starlight? The lack of definitive answers only fueled the speculation. By the time telescopes could turn toward it, Oumuamua was already too far away, vanishing into the void as abruptly as it arrived. What makes this discovery so tantalizing is how little we'll ever know. Most cosmic puzzles eventually yield clues, but Oumuamua left behind only questions. It's a reminder that the universe doesn't owe us explanations. Sometimes it drops a riddle at our feet and leaves before we can solve it. Yet that fleeting encounter changed astronomy forever. Suddenly, interstellar objects weren't just theoretical, they were real, passing through our neighborhood unnoticed until we knew to look. New telescopes now scan the skies for more of these wanderers, hoping to catch the next one before it's gone. Because if there's one thing Oumuamua taught us, it's that the cosmos is full of surprises, and the next great discovery might come hurtling into view when we least expect it. When Voyager 1 sped past Saturn in 1981, scientists expected swirling storms and perhaps a few surprises, but nothing like the bizarre structure that appeared around the planet's north pole. There, spinning with eerie precision, was a colossal hexagon wider than 2 Earths. Its 6 razor-straight sides formed a near-perfect geometric shape, as if someone had etched a giant honeycomb into Saturn's atmosphere. This wasn't just another storm, it was a cosmic puzzle defying every law of fluid dynamics we thought we knew. The hexagon's symmetry was the first clue that something extraordinary was at work. On Earth, weather systems churn in loose spirals or chaotic bands. Even Jupiter's great red spot, while massive, is an oval, a shape nature easily produces. But a hexagon, that's the kind of structure you'd expect in a lab, not wrapped around a gas giant's pole. For decades, researchers wrestled with simulations trying to recreate it. The leading theory suggests that deep beneath Saturn's clouds, jet streams moving at different speeds shear and fold the atmosphere, creating standing waves that lock into this 6-sided pattern. Imagine stirring a cup of coffee just right so the cream doesn't swirl but forms a rigid shape that's the kind of delicate balance Saturn's winds must strike. What's even wilder is the storm's staying power. When the Cassini probe arrived in 2004, 23 years after Voyager's discovery, the hexagon was still there, unchanged. Storms on Earth last days or weeks. Jupiter's great red spot has persisted for centuries. but a geometric tempest stable for decades that hints at forces we're only beginning to grasp. Saturn's deep atmosphere, with its layers of hydrogen under crushing pressure, may act like a vast, self-regulating engine, tuning the hexagon like a musical note held impossibly long. This accidental discovery did more than add a curiosity to Saturn's resume. It rewrote the playbook for planetary science. If a hexagon can emerge from chaos, what other shapes might lurk in the atmospheres of distant worlds? Uranus and Neptune both have odd, lopsided weather patterns. Could they harbor their own geometric surprises? The hexagon stands as a reminder that gas giants aren't just fuzzy balls of hydrogen, they're dynamic, layered worlds with physics we've barely scratched. And that's the real magic of Saturn's six-sided marvel. It's not just a storm, it's a question, a challenge, a whisper from the cosmos that even the things we think we understand, like how fluids move, can still shock us when we look closely enough. So the next time you picture Saturn's rings, remember, beneath those iconic bands at the very top of the planet, there's a polygon spinning silently, waiting for us to unravel its secrets. Mars has always been a tease when it comes to the possibility of extraterrestrial life. For decades, we've stared at its rusty surface, wondering if anything could survive in that frozen, radiation-blasted wasteland. Then in 2003, a European spacecraft called Mars Express picked up something that sent shockwaves through the scientific community, fleeting spikes of methane gas in the planet's thin atmosphere. This wasn't just another dry measurement. Methane is special. On Earth, most methane comes from living organisms, cows, bacteria, decaying plants. It's like nature's neon sign blinking. Life was here. The readings were baffling. Unlike Earth, where methane lingers for years, Mars' methane appeared in sudden bursts, sometimes concentrated in specific regions, other times vanishing without a trace. It behaved like a ghost, appearing when least expected. The most tantalizing detection came in 2013 when NASA, a Curiosity rover, digging in Gale Crater, recorded a tenfold spike in methane levels that lasted just 60 Martian days before dissipating. Then nothing, no gradual decline, no predictable pattern, just a mysterious puff of gas that came and went like a cosmic magician's trick. Scientists scrambled for explanations. Could the methane be seeping from underground reservoirs, the remnants of ancient volcanic activity? Mars does have dormant volcanoes, but the timing didn't match. Geological processes tend to be steady, not erratic. Another theory pointed to meteorites, tiny space rocks constantly raining down on Mars, their carbon-rich material reacting with sunlight to produce methane. But calculations showed this couldn't account for the observed quantities. Then came the electrifying possibility: what if microbes were the culprits? Certain Earth bacteria thrive in extreme environments, producing methane without oxygen. Could similar organisms be hiding beneath Mars' surface, in briny aquifers shielded from radiation? The idea wasn't far-fetched. On Earth, life exists miles underground in places we once thought sterile. Mars might harbor its own shadow biosphere, releasing gas when underground pressures shift or temperatures fluctuate. The debate rages on, with each new mission adding twists to the mystery. In 2018, ESA's Trace Gas Orbiter failed to detect methane from orbit, contradicting surface observations. Was the gas localized, or were the satellites missing something? Then in 2020, Curiosity's samples showed methane levels varying with the seasons, higher in summer, lower in winter. Seasonal changes suggest an active process, not some ancient, frozen relic. Here's what makes this discovery so gripping. It's not just about finding life. It's about how we search for it. Methane could be a false alarm, a red herring spun from geological quirks we don't yet understand. Or it could be the first whisper of a reality that would redefine our place in the universe. Every new detection feels like turning a page in a detective novel where the clues keep contradicting each other, and that's the beauty of accidental science. We set out to study Martian weather and stumbled upon a gas that could rewrite biology textbooks. Whether the answer turns out to be microbes or minerals, one thing's certain: Mars still holds cards close to its chest. The methane mystery isn't just a puzzle to solve. It's an invitation to look deeper, to question our assumptions, and to stay open to the staggering possibility that we might not be alone in this vast cosmic neighborhood after all. In the 1950s, amateur radio operators tuning their equipment began reporting something odd: strange echoes of their own signals bouncing back to Earth minutes after transmission. These delayed echoes defied explanation. Radio waves travel at the speed of light, so any reflection off a known object, like the moon or a satellite, should return almost instantly. But these echoes lagged, as if something unseen was lingering in orbit, catching and holding the signals before tossing them back like a cosmic game of catch. The mystery deepened when newspapers latched onto a tantalizing theory. Maybe these echoes weren't natural at all. Rumors spread of a dark, silent object circling Earth, an ancient alien satellite, dubbed the Black Knight, watching us from the shadows of space. The legend grew with every retelling. Some claimed it was tens of thousands of years old, a relic of an advanced civilization that had visited long before human history began. Others insisted governments were hiding the truth, that this phantom satellite was proof of extraterrestrial contact. By the time the story reached pop culture, it had taken on a life of its own, featured in comic books, sci-fi novels, and even a Marvel Comics storyline. Here's the twist: the Black Knight never existed. Those strange radio echoes, they were likely caused by an obscure but entirely natural phenomenon called long-delayed echoes, where signals bounce between layers of Earth's ionosphere in unpredictable ways, creating the illusion of a distant reflector. As for the satellite itself, the Black Knight image that fueled conspiracy theories was probably just a thermal blanket lost during a spacewalk, photographed years later and misinterpreted. But the real story isn't about debunking myths, it's about why they stick. The Black Knight legend thrived because it tapped into something deeper: our fascination with the idea that we're not alone, that clues to our cosmic neighbors might be hiding in plain sight. Misinterpretations like this aren't just errors, they're reflections of our hunger for mystery in an age where so much of the universe has been mapped and measured. Think about how many times we've projected our hopes onto the unknown. A blurry photo becomes an alien spacecraft. A rock formation on Mars becomes a face carved by ancient beings. These aren't just mistakes, they're stories we tell ourselves to keep the universe feeling vast and uncharted. The Black Knight myth didn't just endure because it was catchy, it endured because it kept the cosmos feeling alive with possibility. And that's the irony. While science strives to explain the universe, sometimes it's the unexplained, the shadows at the edge of our understanding, that capture our imagination most. The Black Knight may have been a phantom, but the wonder it sparked, that was real, and in a way, that's just as valuable as any confirmed discovery. Because sometimes the myths we create tell us more about ourselves than the truths we uncover. Imagine the universe not as a silent void, but as a grand concert hall, where even the emptiest corners thrum with vibrations too deep for human ears. That's the breathtaking reality astronomers stumbled upon in 2023 when they detected something extraordinary: a faint, persistent hum woven into the fabric of space-time itself. This wasn't just background noise, it was the collective echo of countless black holes, some as massive as billions of suns, colliding and merging across the cosmos. The discovery came from an unlikely source: pulsars, Those ultra-precise cosmic lighthouses whose rhythmic pulses we've used to map the galaxy began acting strangely. Over 15 years, researchers monitoring these dead stars noticed their signals weren't arriving with perfect regularity. Some pulses came a fraction of a second early, others slightly late, as if something invisible was stretching and squeezing the space between us and them. The culprit, gravitational waves, ripples in space-time predicted by Einstein but only directly detected in 2015. Except these weren't the sharp chirps of individual black hole collisions. This was a murmur, a choir of waves overlapping into a steady drone, like hearing the roar of an ocean from a single drop of water. What's staggering is the scale of this hum. The signals suggest hundreds of thousands, maybe millions, of supermassive black hole pairs orbiting each other in distant galaxies, inching closer over eons until they finally spiral together in cataclysmic mergers. Each collision sends shockwaves through spacetime, but by the time they reach us, those waves have blended into a whisper. It's as if we're hearing the universe's heartbeat, slowed down a billion times. And here's where it gets even wilder. This hum might be just the beginning. Gravitational wave astronomy is like gaining a new sense, one that lets us perceive the cosmos in ways light alone can't reveal. Already, there are hints of even deeper frequencies in the data, possibly from black holes larger than any we've seen or from exotic phenomena we haven't even imagined. Some theorists speculate the hum could carry traces of the Big Bang itself, vibrations from the universe's birth still resonating today. Think about how poetic this accident is. We built pulsar arrays to study dead stars and ended up eavesdropping on the universe's hidden soundtrack. It's a reminder that space isn't just something we see, it's something we feel, a dynamic medium that trembles with every titanic event. And just like tuning a radio as our instruments get more sensitive, who knows what other cosmic frequencies we'll dial into? The universe has been singing this song for billions of years. We're only now learning to listen. In 2015, a star 1,500 light-years away began acting strangely, not with a grand explosion or a sudden flare, but with a series of bizarre, unpredictable flickers. KIC 8462852, later nicknamed Tabby's star after astronomer Tabitha Boyajian, was caught in the act by an army of citizen scientists sifting through data from NASA's Kepler telescope. These volunteers were part of the Planet Hunters project, scanning for the telltale dips in starlight caused by orbiting planets, but what they found defied all expectations. Instead of the clean, rhythmic dimming of a planet crossing its star, Tabby's star's light dropped by as much as 22% in chaotic, jagged patterns, sometimes for days, other times in sudden, dramatic plunges that lasted mere hours. It was as if something massive and irregular was passing in front of it, blocking its light in ways no natural phenomenon should. The scientific community scrambled for explanations. Could it be a swarm of comets, a shattered planet's debris, or as some daringly speculated, an alien megastructure, a so-called Dyson sphere designed to harness a star's energy? The Dyson sphere hypothesis, though far-fetched, wasn't pure fantasy. Physicist Freeman Dyson had theorized decades earlier that advanced civilizations might build vast solar collectors around stars to capture their energy. The idea captured imaginations, and suddenly, Tabby's star became a global sensation. Here was a real-world anomaly that, for once, matched the kind of signature such a structure might leave. The internet erupted with theories, and even serious astronomers admitted that while aliens were the least likely explanation, they couldn't be ruled out entirely. Years of follow-up observations finally pointed to a more mundane culprit: dust. Not ordinary dust, but immense clouds of fine particles, possibly from a disintegrating moon or a collision between planetary bodies. These clouds, uneven and shifting, could explain the star's erratic dimming without invoking extraterrestrial engineers. Yet the real story wasn't just about solving the mystery, it was about how it was discovered in the first place. Tabby's star wasn't flagged by a supercomputer or a team of PhDs. It was spotted by ordinary people, teachers, students, retirees poring over public data in their spare time. Their sharp eyes caught what algorithms missed, proving that the next cosmic breakthrough might come from anywhere. Projects like Planet Hunters have since uncovered pulsars, exocomets, and even entirely new classes of variable stars, all because someone decided to click through Kepler's light curves on a quiet evening. What's thrilling is how much we still don't know. The universe is vast, and our telescopes capture more data than professionals could ever analyze alone. Every time we open that floodgate to the public, we invite the possibility of another Tabby's star, another cosmic oddball that challenges what we think is possible. Whether it's dust or something stranger, these anomalies remind us that the universe has a habit of surprising us when we least expect it. And sometimes all it takes to find them is a fresh pair of eyes and the willingness to ask, what if? When we picture the moon, we usually imagine a barren landscape of dust and craters, a place where every footprint left by Apollo astronauts remains perfectly preserved in the airless silence. But beneath that lifeless surface, lunar orbiters mapping impact sites stumbled onto something that could change everything. A network of colossal tunnels, some wide enough to fit entire city blocks. These aren't just cracks or crevices, they're the remnants of ancient lava flows, hollowed-out arteries left behind by volcanic activity billions of years ago. And they might just be the perfect cosmic real estate for humanity's first off-world homes. The discovery happened almost by accident. Probes like NAS, a lunar reconnaissance orbiter, were scanning the moon's surface for safe landing sites when their cameras spotted strange, gaping pits, some over 300 feet across. At first, scientists assumed they were just unusually deep impact craters, but when they peered closer, the data told a different story. These pits led to sprawling underground chambers, some stretching for miles beneath the surface. Thermal imaging revealed their ceilings were thick enough to block deadly solar radiation, while their interiors stayed at a stable, survivable temperature. Suddenly, the moon went from a hostile wasteland to a place with ready-made shelters just waiting to be explored. What makes these lava tubes so valuable isn't just their size, it's their potential. Building habitats on the moon's surface means wrestling with extreme temperatures, micrometeorite showers, and radiation levels that could fry electronics and DNA alike. But underground, these tunnels offer natural protection, like a cosmic fallout shelter. Some researchers even speculate they could contain trapped water ice, a precious resource for drinking growing plants or breaking down into rocket fuel. Imagine a future lunar base not as a fragile dome on the surface, but as a thriving complex tucked safely beneath it, with streets lit by artificial sunlight and greenhouses fed by recycled air. The real kicker, the moon might not be alone. Mars has similar pits, possibly carved by its own volcanic past. Even Mercury, scorched by the sun's fury, shows signs of underground caverns. If lava tubes are this common in our solar system, they could be the universe's way of offering us a head start, a series of cosmic safe houses strung across the stars. And that's the beauty of accidental discovery. We set out to map craters and ended up finding humanity's next stepping stone. These tunnels aren't just geological curiosities, they're invitations. Proof that sometimes the universe doesn't just give us challenges, it gives us solutions hiding in plain sight. All we have to do is look down, or in this case, dig in. In 2019, deep beneath the ice of Antarctica, A machine built to hunt the universe's most elusive particles caught something extraordinary, a single neutrino packing enough energy to rival a major league fastball. This wasn't just another subatomic flicker. It was a cosmic bullet fired from one of the most destructive engines in existence, the jet of a supermassive black hole 4 billion light-years away. The discovery marked the first time scientists had ever traced a neutrino back to such a violent source, and it happened entirely by accident. The Ice Cube Neutrino Observatory, a network of sensors buried in the South Pole's ice, wasn't designed to study black holes. Its mission was to detect neutrinos, ghostly particles so indifferent to matter that trillions pass through your body every second without a single interaction. Most slip through Earth unnoticed, but a rare few collide with atoms in the ice, creating faint flashes of light Ice Cube can catch. When the alert sounded on September 22nd, researchers assumed it was just another high-energy neutrino from some unknown corner of space. But this time, luck handed them a clue. As telescopes worldwide scrambled to follow up, they spotted something in the neutrino's path, a blazing jet of particles erupting from a distant galaxy's core, powered by a black hole devouring a star. The implications were staggering. For decades, astronomers had theorized that black hole jets could accelerate particles to near-light speeds, turning them into cosmic particle colliders. But neutrinos are neutral, unaffected by magnetic fields, making them nearly impossible to trace back to their origins. This one was different. Its energy and trajectory lined up perfectly with the jet's direction, like a fingerprint matching a suspect's hand. Suddenly, we had proof that these jets weren't just spewing light, they were firing neutrinos across the cosmos like subatomic Morse code. What's wild is how many stars had to align for this discovery. The neutrino had to hit Ice Cube at just the right angle. The black hole had to be actively flaring, its jet pointed directly at Earth, and telescopes had to be ready to swing into action within hours before the signal faded. It's the scientific equivalent of finding a needle in a galaxy-sized haystack, then realizing the needle was shot from a cosmic cannon. This accidental link didn't just solve a mystery, it opened a new window on the universe. Neutrinos can travel unscathed through dust, gas, and entire galaxies, carrying information from places light can't escape. Now we know some of them are stamped with a return address, violent, energetic ones that scream, "I came from a black hole's maw." It's like discovering smoke signals from a supernova or whispers from the edge of a singularity. And that's the real magic here. For centuries, we've studied the cosmos through light, visible, X-ray, radio. But neutrinos offer something darker, stranger. They're shadows of the universe's most cataclysmic events, slipping past barriers light can't penetrate. With each one we trace, we're not just learning about black holes or exploding stars. We're learning to read the universe in a language it's been speaking all along. We just needed the right accident to hear it. So the next time a neutrino streaks through the ice, remember, it might be carrying secrets from places we've never seen, sent by forces we're only beginning to understand. In 1995, astronomers made a gamble with the Hubble Space Telescope. They pointed it at what seemed like the most unremarkable patch of sky imaginable, a region near the Big Dipper so empty, so devoid of known stars or galaxies, that critics called it a waste of precious telescope time. This blank spot was chosen precisely because it appeared to be nothing more than a cosmic void, a place where Hubble's sensitive optics could calibrate without interference. But when the telescope opened its eye for 10 straight days, collecting every possible photon from that darkness, it didn't find emptiness, it found the universe. The resulting image, now iconic as the Hubble Deep Field, was staggering. Within a patch of sky no larger than a grain of sand held at arm's length, Hubble revealed over 3,000 galaxies, each a swirling island of stars, some so ancient their light had traveled nearly 12 billion years to reach us. The implications were immediate and profound. If this tiny, empty sliver of space held thousands of galaxies, then the entire observable universe must contain hundreds of billions, maybe even trillions. The scale of existence wasn't just vast, it was almost incomprehensible. What's often overlooked is how close we came to never seeing this image at all. Hubble's original mission focused on studying known objects, planets, nebulae, nearby galaxies. The idea of staring at nothing was controversial, with some arguing it was too risky. But astronomer Robert Williams pushed forward, betting that the universe's secrets might hide in its quietest corners. That gamble paid off in ways no one anticipated. The deep field didn't just add galaxies to a catalogue, it rewrote astronomy's playbook overnight. Suddenly, the early universe wasn't just theoretical. Hubble had captured galaxies in their infancy, some so young they existed before Earth's solar system had even formed. Their shapes were chaotic, unlike the neat spirals and ellipticals we see today, offering snapshots of cosmic evolution in action. The image also hinted at something even more unsettling. The vast majority of these galaxies were already so distant, their light too faint for any telescope to see. The deep field was just a taste, a single sip from an ocean we're still barely beginning to explore. This accidental masterpiece didn't just change our textbooks, it changed our perspective. For the first time, humanity grasped the sheer density of the cosmos, how every empty slice of sky is likely teeming with galaxies we can't yet detect. It's like pulling back a curtain and realizing the room you thought was small is actually a hall of mirrors, stretching endlessly in every direction. Subsequent deep field images like the Hubble Ultra Deep Field and the E-Extreme Deep Field pushed even further, revealing galaxies over 13 billion light-years away, their light captured just moments after the cosmic dawn. And that's the real legacy of the Hubble Deep Field. It wasn't just a photograph, it was a mirror reflecting back how little we truly see. Even now, as newer telescopes like James Webb peer deeper, they're building on that same lesson. The universe's greatest wonders often lurk where we least think to look. So the next time you gaze up at a seemingly empty night sky, remember, you're not staring at darkness. You're staring at a tapestry of light woven across billions of years, waiting for us to finally take notice. Stars aren't supposed to move like that. They drift lazily through the galaxy, orbiting its center in predictable loops until astronomers in the early 2000s noticed something that broke all the rules. A handful of stars weren't just moving fast, they were hurtling through space like bullets, clocking speeds over 1 million miles per hour. At that velocity, gravity itself couldn't hold them. These weren't ordinary stars, they were cosmic fugitives, racing toward the void beyond the Milky Way with no intention of ever coming back. The first of these hypervelocity stars was discovered almost by accident. Scientists were mapping stellar motions when one star in particular stood out, a lone blue giant streaking through the constellation Hydra at 3 times the speed of its neighbors. Its trajectory pointed like an arrow straight out of the galaxy. At first, researchers assumed it must have been a glitch, a miscalculation, but as more of these speed demons were spotted, a pattern emerged. These weren't mistakes. They were evidence of something far more violent happening in the heart of our galaxy. The leading theory, a cosmic slingshot powered by the supermassive black hole lurking at the Milky Way's center. Imagine a binary star system, 2 stars locked in orbit around each other, wandering too close to the black hole's gravitational grasp. One star gets captured, swirling into the abyss, while the other is flung outward at unimaginable speed, like a stone from a sling. The energy transfer is so extreme, the ejected star doesn't just drift away, it's catapulted with enough force to escape the galaxy entirely. But here's where it gets even stranger. Not all hypervelocity stars come from the galactic center. Some seem to originate in the spiral arms, far from any obvious black hole. That's led to wilder theories. Perhaps these stars were kicked by mid-sized black holes we haven't found yet. Or maybe they're survivors of dwarf galaxies torn apart by the Milky Way's gravity, their stars scattered like debris from a collision. What's astonishing is how much these rogue stars reveal about forces we can't directly see. By tracing their paths backward, astronomers can map the hidden landscape of gravitational monsters, black holes, dark matter clumps, even entire shredded galaxies that sculpt our cosmic neighborhood. Each hypervelocity star is like a message in a bottle, carrying clues about the violent events that launched it, and the implications are mind-bending. If stars can be hurled across intergalactic space, what else might be out there, flung into the darkness by forces we're only beginning to understand? Planets' organic molecules, these runaway stars, don't just escape the galaxy. They carry the possibility of spreading life's ingredients far beyond their birthplaces. The universe has a way of turning even the most orderly systems into chaos. One moment, a star is peacefully orbiting its companion. The next, it's sent careening into the void, a lonely traveler on a journey with no end. It's a reminder that for all its vastness, the cosmos is also intimately connected, a place where a black hole's whim can send a star racing past our telescopes, whispering secrets about the forces that shape everything we see. Even in the vast emptiness between galaxies, where space seems almost still, astronomers have caught something utterly bizarre, an inexplicable river of motion pulling entire galaxy clusters in the same direction. This strange phenomenon, called the dark flow, was discovered in 2008 while scientists were studying leftover radiation from the Big Bang. They expected the cosmos to expand uniformly, with galaxies drifting apart in all directions like dots on an inflating balloon. But the data revealed something far more unsettling: hundreds of galaxy clusters, each containing thousands of galaxies, were all streaming toward a single point beyond the edge of the observable universe. It was as if something massive, something unseen, was tugging them from the shadows. The discovery came from careful analysis of the cosmic microwave background, the faint glow of the infant universe. Tiny temperature fluctuations in this radiation act like cosmic breadcrumbs, revealing how matter moves through space. Researchers noticed these fluctuations weren't random. They lined up in a way that suggested motion on an unimaginable scale. Galaxy clusters spanning billions of light-years weren't just drifting, they were being pulled, like iron filings drawn to a magnet we can't see, the most startling part. Whatever's causing this flow lies beyond the cosmic horizon, in regions of space so distant their light hasn't had time to reach us since the beginning of the universe. Theories range from the mind-bending to the downright terrifying. Some suggest the dark flow could be evidence of a neighboring universe beyond our own, its gravitational influence leaking into our cosmic bubble. Others propose it's the fingerprint of a superstructure so colossal it defies current physics, a concentration of mass so vast it warps the fabric of reality on scales we've never imagined. Then there's the sobering possibility that our measurements are flawed, that some subtle error in interpreting the data has created an illusion of motion where none exists. Yet after years of scrutiny, the dark flow stubbornly remains, a cosmic anomaly that refuses to be explained away. What makes this mystery so thrilling is how it challenges the very foundations of cosmology. The observable universe is supposed to be roughly uniform, with no preferred direction or hidden imbalances. The dark flow throws that assumption into chaos, hinting that there might be structures or forces operating on scales larger than we thought possible. It's like standing on a beach and realizing the tide isn't just coming in. It's being pulled towards something enormous just beyond the horizon, and that's the real magic of accidental discoveries like this. They don't just add to our knowledge, they rip open new questions, revealing gaps in our understanding we never knew were there. Whether the dark flow is a clue to parallel universes, undiscovered physics, or something else entirely, one thing's certain: the cosmos still holds mysteries that refuse to fit neatly into our textbooks. The universe, it seems, still has a few surprises up its sleeve, and they're lurking just out of sight, tugging at the edges of everything we think we know. In 2019, astronomers scanning the night sky with radio telescopes stumbled upon something that looked like it belonged in a sci-fi novel. Massive, perfectly circular rings glowing in radio waves, each spanning hundreds of thousands of light years. These weren't supernova remnants or distant galaxies. They were entirely new cosmic phenomena, so puzzling that researchers dubbed them odd radio circles, or ORC. And the more they studied them, the stranger these rings became. At first glance, ORCs seemed like the aftermath of colossal explosions, shockwaves rippling through intergalactic space. But there was a problem. No known event could produce rings this large or this symmetrical. Supernova leave messy debris fields, and galaxy collisions create chaotic swirls, not flawless loops. Then came the real head-scratcher. Some ORCs appeared to encircle entire galaxies like halos of energy. That's when the whispers started. Could these be signs of advanced alien engineering, some kind of interstellar megastructure? The idea wasn't completely far-fetched. After all, if a civilization had the power to harness a galaxy's energy, they might leave traces visible across cosmic distances. But as always, the universe had a knack for defying easy explanations. Further observations revealed that ORCs weren't broadcasting any artificial signals, just natural radio waves. The leading theory now suggests they might be the aftermath of titanic galactic winds, streams of particles blasted outward by furious bursts of star formation. When these winds slam into surrounding gas, they could create shock waves that glow in radio frequencies, forming those eerie rings. Another possibility. They might be the fingerprints of supermassive black holes, their jets punching through intergalactic space and leaving behind vast circular ripples. What's fascinating is how long it took to even notice these cosmic bullseyes. ORCs are faint, and without the sensitivity of modern radio telescopes like ASCAP in Australia, they'd have remained invisible. It's a reminder that the universe is still full of surprises hiding in plain sight, waiting for the right tools or the right accident to bring them into focus. And that's the beauty of ORCs. They're not just another celestial curiosity, they're a snapshot of how much we still don't understand. Whether they're shock waves from galactic upheavals, black hole echoes, or something even weirder, one thing's clear: the cosmos loves to keep us guessing. Every time we think we've mapped the edges of what's possible, it throws another ring-shaped mystery our way, daring us to look closer. When NASA launched the Parker Solar Probe in 2018, its mission seemed straightforward: get closer to the sun than any spacecraft before it, braving temperatures hot enough to melt steel to unravel the mysteries of the solar corona. But within months of its first close approach, the probe sent back data that left scientists stunned. Not just answers, but a whole new set of questions. Hidden in the torrent of particles streaming from the sun were bizarre, zigzagging kinks in the solar wind, sudden magnetic reversals so sharp researchers dubbed them switchbacks. No one had predicted these structures, no model accounted for them. It was as if the sun had been hiding a secret language in plain sight, written in twists of magnetism. These switchbacks weren't just minor fluctuations, they were massive, S-shaped flips in the sun's magnetic field, some stretching thousands of miles across. Imagine a highway where the lanes suddenly switch direction, forcing cars to U-turn for no apparent reason. That's what the solar wind was doing, and at speeds over 1,000,000 miles per hour. At first, the team thought it might be a glitch, some artifact of the probe's instruments straining under the sun's fury. But as Parker dove closer, the switchbacks only multiplied, appearing like waves crashing in a magnetic surf. The discovery turned decades of solar physics on its head. Conventional wisdom said the solar wind should flow smoothly outward, its magnetic lines stretching like taffy as it raced away from the sun. Instead, Parker revealed a chaotic dance, with fields folding back on themselves in ways that defied explanation. One theory suggests these kinks might be caused by explosions of plasma near the sun's surface, flinging magnetic loops into space like cosmic lassos. Another proposes they're remnants of the sun's magnetic field rearranging itself, snapping like overstretched rubber bands. What's wild is how these accidental findings are reshaping our understanding of the sun's influence. Switchbacks might explain why the solar wind accelerates so fast, or how energy from the corona gets pumped into space. They could even hold clues to space weather, those geomagnetic storms that knock out satellites and power grids on Earth. If we can decode these magnetic Morse signals, we might finally predict solar tantrums before they hit us. But the real lesson here isn't just about the sun. It's about how often the universe reveals its secrets not when we're looking for them, but when we're looking at something else entirely. Parker was built to study heat and solar wind speed, not magnetic acrobatics. Yet by venturing where no probe had gone before, it stumbled onto a phenomenon no one knew existed. That's the magic of exploration. Sometimes the biggest discoveries aren't the answers we set out to find, they're the questions we didn't even know to ask. And as Parker keeps diving toward the sun, skimming just 4 million miles from its surface, who knows what other surprises are waiting in the fire? For decades, scientists have relied on a series of mirrors left on the moon by Apollo astronauts to measure its distance from Earth with pinpoint accuracy. By firing lasers at these reflectors and timing how long it takes for the light to bounce back, they can track the moon's orbit down to the millimeter. But in 2010, something unexpected happened. A telescope team in New Mexico picked up a signal from a reflector no one was even looking for. Nestled in the lunar soil near the Sea of Rains was a long-forgotten relic of the Cold War space race, a Soviet-made reflector lost for over 40 years. This small, suitcase-sized device, called Lunar-1, had been delivered by the USSR's robotic Lunar 17 mission in 1970. For nearly a year, it roamed the moon's surface, sending back data before going silent in 1971. As the decades passed, its exact location faded into obscurity, written off as just another piece of abandoned space hardware. Then NASA, a lunar reconnaissance orbiter, happened to snap high-resolution images of the area, revealing the rover's final resting place. On a whim, researchers at the Apache Point Observatory aimed their laser at the coordinates, and to everyone's shock, light came bouncing back. The rediscovery wasn't just a historical curiosity, it was a scientific goldmine. Unlike the Apollo reflectors, which sit in fixed positions, Lunar-1's mobility meant it had been placed much farther north than any other reflector on the moon. That new vantage point allowed for more precise measurements of the moon's subtle wobbles and tilts, phenomena known as librations. Suddenly, scientists had a fresh tool to study the moon's internal structure, from the rigidity of its core to the way its shape shifts under Earth's gravitational pull. What's remarkable is how easily this breakthrough could have been missed. The laser pulses sent to the moon are so faint that only about 1 in 30 million photons makes the round trip. Detecting a signal from a reflector that hadn't been used in generations was like finding a needle in a cosmic haystack. Yet there it was, a piece of Cold War history quietly waiting to improve 21st century science. The story of Lunar 1 is a reminder that even in space, nothing is ever truly lost. Forgotten artifacts, abandoned experiments, they're all still out there, holding secrets we might not realize we need until we stumble upon them. And sometimes the key to unlocking new discoveries isn't some cutting-edge technology, but a willingness to look back at what we've left behind. Who knows what other forgotten treasures are still waiting on the moon, silently reflecting light back to Earth, ready to reveal their secrets when we're finally curious enough to ask. Fast radio bursts have always been the universe's most frustrating cosmic flashbulbs, blindingly bright, impossibly brief, and utterly unpredictable. These bursts of radio waves, lasting just milliseconds, pack more energy than the sun emits in days, yet most vanish without a trace, leaving astronomers scrambling to explain what could possibly produce such violent, one-and-done flashes. That's why the night of November 2nd, 2016 changed everything. At the Arecibo Observatory in Puerto Rico, a telescope designed to study pulsars caught something no one expected. A fast radio burst that didn't just flash once. It repeated. At first, the team thought it was a glitch. FRBs weren't supposed to do this, but over the next few months, the same source, dubbed FRB 121102, erupted again and again, sometimes with multiple bursts in a single hour. Suddenly, these cosmic mysteries weren't just transient blips. Some had engines that kept running, sources capable of firing over and over. It was like hearing a gunshot in the dark, then realizing the shooter was still there, reloading. The implications were staggering. If FRBs could repeat, then whatever produced them wasn't destroyed in the process. Cataclysmic one-time events like colliding neutron stars or evaporating black holes were off the table. Instead, the culprit had to be something durable, a magnetar perhaps, with its unimaginably strong magnetic field twisting and snapping like a cosmic rubber band. Or maybe something even stranger, a pulsar slamming through asteroid belts, its shockwaves igniting bursts of radio energy. Then came the real twist. In 2020, another repeater, this one inside our own galaxy, was traced definitively to a magnetar. Finally, astronomers had a smoking gun, but here's the catch: not all repeating FRBs behave the same way. Some are erratic, firing off bursts at random intervals. Others follow patterns like clockwork ticking in slow motion. And some, like the infamous FRB 121102, seem to cycle through active and quiet phases, as if governed by seasons we don't yet understand. What's thrilling is how much we've learned from this one accidental discovery. Repeaters have given us a way to triangulate their origins, using the subtle delays between different radio frequencies to map their journey through intergalactic space. Each burst is like a message passed through cosmic fog, carrying clues about the invisible matter it's traveled through. And because some repeaters have been caught flaring for years, astronomers can now study them in real time, watching as their behavior evolves. Yet for every answer, there's a new question. Why do some FRBs repeat while others don't? Are they all fundamentally the same phenomenon, or is the universe hosting multiple kinds of radio fireworks? And what does it mean that some repeaters seem to live in environments unlike anything we've seen before? One is even nestled inside a bizarre, blob-like galaxy that defies classification. That's the beauty of cosmic accidents. We set out to study pulsars and stumbled onto a whole new class of radio enigmas. Now, every time a telescope catches another repeating burst, it's not just adding to a catalogue, it's offering another piece of a puzzle we're only beginning to assemble. And who knows, the next burst might just be the one that finally cracks the code. Galaxies are supposed to be bright, bustling cities of stars. So when astronomers in 2015 pointed their telescopes toward the Comet cluster, a dense gathering of galaxies 300 million light-years away, they expected to see the usual glow of spirals and ellipticals. Instead, they found ghosts. Scattered among the cluster's luminous giants were bizarre, wispy smudges so faint they'd been overlooked for decades. These weren't just dim galaxies, they were cosmic phantoms, sprawling as wide as the Milky Way, but with stars so sparse you could fly through one and barely notice. The discovery was accidental, a byproduct of the hunt for dark matter, but it shattered every assumption about how galaxies could exist. These ultra-diffuse galaxies, or UDG, defy logic. A typical galaxy like ours packs hundreds of billions of stars into a dense disk, but UDGs spread the same number of stars, or sometimes just 1% as many across an equally vast space. Imagine replacing New York City's skyline with a handful of streetlights spaced miles apart. That's the eerie emptiness of a UDG. At first, researchers thought they might be failed galaxies, places where star formation fizzled out early. But when teams studied their motions, they got another shock. Despite their near invisibility, some UDGs were crammed with dark matter, their gravity far stronger than their handful of stars could explain. One, nicknamed Dragonfly 44, had a dark matter halo rivaling the Milky Way's, yet its stars contributed almost nothing to its mass. It was like finding a shadow with the weight of a mountain. The real puzzle, how these fragile structures survive at all. The Comet cluster is a violent place, with galaxies ripping each other apart through gravitational tides. Conventional wisdom says UDGs should have been shredded eons ago, yet there they were, not just intact but surprisingly common. Later surveys revealed hundreds more, some floating in isolation, others drifting in clusters like silent spectators. Their resilience hints at unseen forces at work, perhaps dark matter arranged in ways we've never observed. Or maybe their stars are just the visible tip of an iceberg, with something even stranger lurking beneath. What's thrilling is how these ghostly galaxies force us to rethink the rules. For centuries, we've defined galaxies by their stars, their brightness, their shape, their density. UDGs laugh at those categories. They're galaxies that barely act like galaxies, challenging us to ask, what really makes a galaxy a galaxy? Is it the stars, the dark matter, or something we haven't even considered yet? And that's the beauty of accidental discoveries. We set out to map dark matter and stumbled upon cosmic wraiths hiding in plain sight. They're reminders that the universe doesn't care about our definitions. It'll always find ways to surprise us. So the next time you look up at the night sky, remember, for every bright spiral or glowing nebula, there might be a ghost floating unseen, waiting for its moment to step into the light. The outer reaches of our solar system have always been a graveyard of frozen leftovers, icy rocks tumbling through the dark, relics from the solar system's birth. But in 2014, astronomers poring over these distant orbits noticed something that shouldn't be there. A handful of Kuiper Belt objects, small worlds like Sedna and Biden, were following paths that defied logic. Their elongated orbits all pointed in the same direction, as if tugged by some unseen hand. The odds of this happening randomly, less than 1 in 10,000. Something massive had to be warping their trajectories, something like a hidden planet, lurking in the shadows beyond Neptune. This wasn't the first time astronomers had hunted for a phantom planet. Over a century ago, irregularities in Uranus's orbit led to the discovery of Neptune. Later, tiny wobbles in Neptune's path sparked the search for Pluto. But this time, there was no visible culprit. The gravitational fingerprints pointed to a world up to 10 times the mass of Earth, tracing a looping, elliptical path so far from the Sun that a single orbit could take 20,000 years. Researchers dubbed it Planet 9, and suddenly the race was on to find the solar system's last giant. What's fascinating isn't just the possibility of a new planet, it's how easily it could have stayed hidden. Unlike Pluto, which reflects enough sunlight to glint in telescopes, Planet 9 would be so distant and faint that even our best observatories might miss it. Its warmth would come not from the Sun but from the slow decay of radioactive elements in its core, glowing dimly in infrared. To spot it, astronomers have had to rely on indirect clues, those odd Kuiper belt orbits, and then scan vast swaths of sky, searching for a single pixel moving imperceptibly against the stars. Critics argue the evidence is circumstantial. Maybe the odd orbits are statistical flukes, or perhaps they're caused by the collective gravity of smaller objects we haven't catalogued yet. But supporters counter that no other explanation fits the data so neatly. Planet 9's gravity wouldn't just shepherd those Kuiper belt objects. It could also explain why the solar system's plane is tilted slightly, or why some distant objects orbit backward compared to the planets. It's as if the solar system's final puzzle piece is hiding just beyond our reach, warping everything around it. The hunt has already rewritten our understanding of the solar system's edges. If Planet 9 exists, it likely didn't form where it is now. Simulations suggest it could have been hurled outward by Jupiter's gravity in the solar system's chaotic youth, a cosmic game of pinball leaving a giant adrift in the dark. That raises even wilder questions. How many other exiled planets might be out there? Could interstellar space be littered with worlds ejected from their stars, invisible nomads drifting between the galaxies? For now, Planet 9 remains a tantalizing hypothesis, a shadow in the data, a gravitational ghost. But whether it's confirmed or not, its legacy is already cemented. Those odd Kuiper belt orbits didn't just hint at a missing planet. They reminded us that even in our own cosmic backyard, there are still mysteries waiting to be uncovered. The solar system isn't a solved puzzle. It's a story with pages yet to be read, and somewhere in the darkness, a new chapter might still be waiting. 2 years after Oumuamua's fleeting visit, the universe sent us another gift, but this time there was no mistaking what it was. In August 2019, Crimean amateur astronomer Gennady Borisov spotted a fuzzy streak moving against the stars, its trajectory immediately raising eyebrows. Unlike the thousands of comets logged before it, this one wasn't orbiting the Sun. It was racing past at breakneck speed, following a path so extreme it could only have come from another star system. By sheer luck, Borisov's telescope happened to be pointing at the right patch of sky at the right moment, capturing what would soon be confirmed as humanity's first observed interstellar comet, Borisov. What made this visitor so special wasn't just its origin, it was how unmistakably comet-like it behaved. Where Oumuamua had been a dry, rocky enigma, Borisov was everything scientists hoped for, a textbook dirty snowball, erupting with gases and trailing a glittering tail as sunlight vaporized its ices. Telescopes worldwide swiveled to study it, analyzing its chemistry for clues about its home system. The results were stunning. Borisov's coma, the cloud of gas around its nucleus, contained unusually high amounts of carbon monoxide, suggesting it formed in an environment far colder than our solar system's outskirts. Its dust grains were also smaller and more uniform than those found in local comets, hinting at a birthplace with different physical conditions. But the real surprise came when astronomers calculated how many interstellar interlopers like Borisov might be passing through at any given time. Based on its discovery, just 2 years after Oumuamua, researchers estimate our solar system could host thousands of such visitors at any moment, most too faint to spot with current telescopes. That's like realizing your quiet suburban street is actually a cosmic highway with invisible travelers zooming past your mailbox daily. The implications rewrite our understanding of cosmic building blocks. If interstellar comets are this common, they could be ferrying raw materials between star systems: water, organic molecules, even the ingredients for life, like celestial postmen delivering packages across the galaxy. Some scientists speculate that during the solar system's chaotic infancy, objects like Borisov might have seeded Earth with water or complex chemistry. Others wonder if we're witnessing the aftermath of planetary upheavals elsewhere, with comets ejected like shrapnel from distant cosmic collisions. What's thrilling is how ordinary Borisov appeared just another dot in an amateur astronomer's eyepiece until its motion betrayed its extraordinary story. It's a reminder that the cosmos doesn't reserve its wonders for professional observatories. Sometimes, groundbreaking discoveries happen because someone in their backyard decides to look up at the right moment. And with next-generation telescopes like the Vera Rubin Observatory coming online, we're on the verge of spotting dozens more of these nomads. Each one will be a postcard from a place we'll never visit, carrying secrets about how star systems, including our own, are built. So the next time you gaze at the night sky, consider this. Among those twinkling lights and familiar constellations, there might be another Borisov or Oumuamua slipping unseen through the dark. The universe is full of unannounced guests, and every now and then, if we're lucky, one of them decides to drop by. When the Kepler Space Telescope first caught KIC 8462852 flickering like a dying light bulb, scientists knew they were looking at something unprecedented. Most stars dim in predictable ways, maybe a planet passing in front or a sunspot rotating into view. But this star, later nicknamed Tabby star after astronomer Tabetha Boyajian, didn't play by the rules. Its light dropped by staggering amounts, up to 22% at times, in jagged, irregular dips that lasted anywhere from hours to weeks. No natural phenomenon could explain it. It was as if something massive and misshapen kept drifting in front of it, blotting out its light in ways that defied every model in the books. The discovery sent shockwaves through astronomy because it didn't just break the mold, it shattered it. Planets, even giant ones, only block about 1% of a star's light. Dust clouds, they're usually diffuse, causing gradual dimming, not these sudden, dramatic plunges. The patterns were so bizarre that when Boyajian and her team published their findings, they included a now famous line: "We're not saying it's aliens, but..." Cue the internet frenzy. The idea of a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harness a star's energy, suddenly didn't seem so far-fetched. If something was deliberately obstructing Tabby's star, maybe we'd stumbled onto the ultimate cosmic construction project. But here's where the story twists. As tantalizing as the alien hypothesis was, the universe tends to favor simpler explanations. Years of follow-up observations pointed to a more mundane culprit: dust. Not ordinary dust, but immense, uneven clouds of it, possibly from a shattered moon or a catastrophic collision between planets. These clouds could explain the erratic dimming without invoking extraterrestrial engineers. Yet even this answer raised new questions. Why was the dust so clumpy? Why did it block certain wavelengths of light more than others? And why did the star's long-term brightness keep fading over years, as if something was slowly smothering it? The real magic of Tabby's star isn't just the mystery, it's how the mystery was uncovered. Kepler wasn't even designed to study individual stars in this much detail. It was built to find planets by spotting their predictable transits. The anomaly only came to light because citizen scientists, sifting through Kepler's data as part of the Planet Hunters project, flagged it as weird. Without their sharp eyes, the data might have been written off as noise. Instead, it became one of the most debated stellar phenomena in modern astronomy. What's fascinating is how Tabby's star forced scientists to think outside the box. It wasn't just about aliens versus dust. It was about realizing how much we still don't understand about stellar environments. Could there be entirely new classes of cosmic debris we've never imagined? Could some stars naturally shed material in bizarre, asymmetrical ways? The more we studied it, the clearer it became. Tabby's star wasn't an anomaly. It was a preview. In the years since, astronomers have spotted other Dipper stars with similar behavior, though none as extreme. Each new find chips away at the mystery, suggesting that whatever's happening around Tabby's star, it's part of a broader cosmic story we're only beginning to read. And that's the beauty of accidental discoveries. They don't just answer questions, they rewrite them. Long after the alien megastructure headlines faded, Tabby's star kept teaching us one vital lesson. The universe is always more inventive than we are. Just when we think we've got it figured out, it throws another curveball, and suddenly the game changes all over again. In the vast cosmic dance of galaxies, everything moves, but not always in ways we expect. Back in the 1970s, astronomers mapping the universe's large-scale structure noticed something unsettling. Our Milky Way, along with thousands of neighboring galaxies, wasn't just drifting apart due to the universe's expansion. It was being pulled en masse toward a specific point in space. This mysterious force, dubbed the Great Attractor, lay hidden behind the dense stars of our own galaxy's plane, obscured by cosmic dust and starlight. It was as if the universe had a hidden center of gravity, a cosmic magnet tugging everything toward it without revealing itself. The discovery came from studying peculiar velocities, the slight deviations in galaxies' motions caused by local gravitational tugs. When researchers subtracted the expected expansion of the universe, a startling pattern emerged. Galaxies across our local supercluster were all streaming toward the same invisible focal point, roughly 250 million light-years away in the direction of the constellation Centaurus. The sheer scale of this motion suggested something colossal, a concentration of mass so immense it could bend the paths of galaxies like a whirlpool pulling in leaves. Yet when telescopes scanned the region, they found nothing visible that could account for such a gravitational behemoth. For decades, the Great Attractor remained one of cosmology's most frustrating puzzles. Was it a single supermassive structure, like a gargantuan cluster of galaxies we simply couldn't see? Or was it the cumulative pull of countless smaller objects, their combined gravity adding up to an irresistible force? The answer turned out to be even more extraordinary. As observational technology improved, particularly in X-ray and radio wavelengths, astronomers peeled back the Milky Way's dusty veil and found not just one attractor, but an entire cosmic watershed. The Great Attractor was merely the tip of an iceberg, part of a mind-boggling structure now called Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea is our galactic supercluster, a sprawling web of galaxies spanning 500 million light-years, all bound together by gravity and flowing toward a common center of mass near the Great Attractor. Within it, the Milky Way is just one of 100,000 galaxies drifting along filaments of dark matter, like a leaf caught in a slow-moving river. But here's the twist. Laniakea itself is being pulled toward something even larger, the Shapley supercluster, an even more massive congregation of galaxies over 600 million light-years away. The cosmos, it seems, is built like a nested set of Russian dolls, with each layer of structure revealing a deeper, more complex hierarchy of motion. What's humbling about this discovery is how much we still can't see. The Great Attractor's gravity implies the presence of tens of thousands of galaxies we've yet to map, hidden behind the Milky Way's glare. And beyond Laniakea, there may be even grander structures waiting to be uncovered, their gravitational whispers only now reaching our instruments. It's a reminder that for all our telescopes and technology, we're still mapping the cosmos from inside a fishbowl, peering out through layers of cosmic fog. Yet the real wonder isn't just the scale, it's the sheer serendipity of the find. Astronomers weren't looking for a hidden attractor, they were simply trying to measure galaxy motions. The universe handed them a riddle wrapped in gravity, a clue that what we see is only a fraction of what's out there. Every time we think we've grasped the full picture, the cosmos tugs us toward another mystery, proving once again that the most profound discoveries often start with a simple question: why is everything moving that way? In 2004, astronomers scanning the sky with NAS, a galaxy evolution explorer, stumbled upon something that looked like a celestial fingerprint, a star enveloped by a perfect, glowing blue ring. This wasn't just another planetary nebula or supernova remnant. The ring pulsed with ultraviolet light, an eerie halo that defied easy classification. For 16 years, the so-called Blue Ring Nebula remained one of astrophysics' most stubborn puzzles. Theories came and went. Maybe it was a dying star's expelled layers, or perhaps the aftermath of a black hole's snack. But nothing quite fit. Then in 2020, armed with new tools and fresh perspectives, researchers cracked the code. The truth was far more explosive than anyone had guessed. They were witnessing the aftermath of a cosmic collision, a stellar merger so recent that its echoes still rippled across space. What made this discovery so extraordinary wasn't just the event itself, it was the timing. Stellar mergers are rare, fleeting spectacles, often hidden behind veils of dust or lost in the glare of younger stars. But the Blue Ring Nebula offered a snapshot of the immediate aftermath, a cosmic crime scene still fresh. Here's how it likely unfolded. Two stars, locked in a tight dance for millions of years, finally spiraled too close. The smaller star was shredded, its material flung outward while the larger star absorbed the rest. The force of the collision ejected a torus of superheated debris, the blue ring, while shockwaves ionized surrounding gas, making it glow in ultraviolet. But the real breakthrough came when scientists realized they weren't just seeing a ring. Advanced spectroscopy revealed twin cones of material spewing from the star's poles, invisible to earlier telescopes. This was the smoking gun. Mergers don't just scatter debris evenly, they channel it into jets like water from a spinning lawn sprinkler. The blue ring was merely the base of these cones, a circular slice of a much larger, three-dimensional structure. Suddenly, the pieces fell into place. The star at the center wasn't a typical giant. It was a Frankenstein's monster, stitched together from the remnants of two stars, its surface still roiling with the energy of the cataclysm. The implications stretch far beyond this one cosmic oddity. Stellar mergers are thought to forge strange objects like blue stragglers, stars that appear younger and hotter than their neighbors, or even rare types of supernova. The Blue Ring Nebula offers a missing link, a way to study these violent events not in distant simulations, but in real time. It's like catching a sculptor mid-chisel, revealing how cosmic chaos can shape the universe's most exotic creations. What's poetic is how long the answer was hidden in plain sight. The data existed for years, waiting for technology and theory to align. It took a combination of ground-based telescopes, space observatories, and sheer persistence to decode the nebula's secrets. And that's the beauty of astronomy's long game. Some discoveries aren't just about what we find, they're about when we finally understand. The Blue Ring Nebula reminds us that the universe doesn't hand out answers on demand. Sometimes it lets us sit with the questions, turning them over until we're ready to see what was there all along. Most galaxies announce themselves with a blaze of starlight spiraling arms of blue and white, glowing cores of yellow and red. But in 2016, astronomers peering into the Virgo cluster found something that defied every expectation: a cosmic ghost drifting silently through space. This wasn't a dim galaxy or a dust-shrouded mystery. It was an enormous cloud of hydrogen gas, wider than the Milky Way, moving with the grace of a fully formed galaxy, yet completely devoid of stars. No glittering clusters, no newborn stellar nurseries, not even the faintest glow of a single sun. Just cold, dark gas swirling in perfect silence. The discovery was accidental. Researchers were using the Arecibo radio telescope to study hydrogen distributions when they spotted an anomaly, a vast reservoir of gas behaving unlike anything in the catalogs. Its rotation curve, the way its outer edges moved in relation to its center, matched the elegant dance of a spiral galaxy. But without stars to light it up, this dark galaxy had been invisible to optical telescopes for decades. The cloud, named Virgo 21, wasn't just a gas pocket. It had the mass and structure of a full-fledged galaxy, as if someone had erased every star from the Milky Way and left only its skeleton behind. So what went wrong? Why did this potential galaxy fail to ignite? The leading theory is heartbreakingly simple. It never had a chance. Galaxies form when gas collapses under gravity, heating up until nuclear fusion sparks and stars are born. But Virgo 21 might have been born in a cosmic dead zone, a region where the gas was too diffuse, too spread out to clump together densely enough. Without those first critical stars to pump energy back into the system, the cloud simply stalled, a cosmic engine that never turned over. But here's where it gets even stranger. Virgo 21 isn't alone. Since its discovery, astronomers have identified a handful of similar dark galaxies, each a shadowy echo of what could have been. Some might be failed galaxies like Virgo, while others could be the shredded remnants of galaxies torn apart by collisions, their stars stripped away while their gas lingers like smoke after a fire. There's even speculation that these invisible structures could be the hidden scaffolding of the universe's dark matter halos that never gathered enough ordinary matter to light up. The implications rewrite our understanding of cosmic evolution. If dark galaxies are common, they could solve a long-standing puzzle: why the universe has fewer small galaxies than our models predict. Maybe the missing galaxies aren't missing at all, they're just sitting in the dark, frozen in time. And if these structures can persist for billions of years without forming stars, what does that say about the delicate balance required to build a galaxy like ours? It's humbling to realize how much of the cosmos might be hiding in plain sight. For every glittering spiral or radiant elliptical, there could be dozens of these silent shadows, galaxies that never were, their stories written in gas and motion rather than light. They remind us that the universe isn't just a gallery of brilliant masterpieces. It's also a workshop full of half-finished sketches, abandoned canvases, and ideas that never quite took shape. And sometimes the most revealing discoveries aren't the brightest, they're the ones we almost didn't see at all. In the vast tapestry of the cosmos, planets are supposed to follow the rules orbiting stars in predictable paths, bound by gravity's unbreakable tether. But in 2011, astronomers peering through infrared telescopes spotted something that shattered that assumption. Drifting through the darkness of interstellar space, untethered to any star, was a Jupiter-sized world moving silently through the void. This wasn't just a planet far from its sun, it was a true cosmic nomad, a rogue planet floating freely through the galaxy like a ghost untethered from the land of the living. The discovery wasn't just surprising, it was revolutionary. Until then, rogue planets had been purely theoretical, their existence debated in academic papers but never confirmed. Scientists had speculated that gravitational chaos, close encounters between planets or passing stars, could fling worlds out of their systems, sending them careening into the abyss. But without direct evidence, it remained just an idea. That changed when telescopes scanning a star-forming region called the Orion Nebula detected the faint infrared glow of this solitary giant. Unlike stars, which emit their own light, rogue planets are only visible by the residual heat left over from their formation. Spotting one is like trying to find a dying ember in a pitch-black room. What makes this discovery so fascinating isn't just the planet itself, it's what it implies. If a Jupiter-sized rogue planet can be found, how many smaller, Earth-sized wanderers might be out there, invisible to our current telescopes? Some estimates suggest there could be billions of these free-floating worlds in our galaxy alone, outnumbering stars by a staggering margin. Imagine entire planets untethered from any solar system, drifting through the cold expanse of space. Some might be frozen wastelands, their atmospheres collapsed into icy shells. Others, heated by internal radioactivity or tidal forces, could even harbor subsurface oceans, dark, isolated habitats where life clings to existence in perpetual night. The origins of these rogue planets are just as compelling as their existence. Some may have been ejected from their birth systems in the turbulent early days of planetary formation, when young gas giants jostled for position in unstable orbits. Others might have formed directly from collapsing gas clouds, never belonging to a star in the first place. There's even speculation that interstellar space could be littered with planets stripped from their parent stars during galactic collisions, orphaned in the chaos of merging galaxies. The implications stretch far beyond mere curiosity. Rogue planets could be the ultimate dark matter candidates, not the exotic particles physicists hunt for, but massive, invisible objects hiding in plain sight. They might also serve as stepping stones for future interstellar travel, offering waypoints for spacecraft venturing between the stars. And if life exists on any of these wandering worlds, it would redefine our understanding of where and how life can emerge. No sunlight, no problem extremophiles on Earth thrive in places we once thought uninhabitable. Why not a rogue planet warmed by geothermal vents or radioactive decay? What's astonishing is how easily this discovery could have been missed. Without infrared technology, this lone planet would have remained invisible, its existence forever speculative. Yet once again, the universe revealed one of its secrets, not because we were looking for it, but because we were looking at all. Every rogue planet detected is a reminder of how much we still don't know. How many unseen worlds might be passing through our cosmic neighborhood, silent and undetected? So the next time you gaze up at the night sky, remember, for every star with its family of planets, there could be countless others traveling alone, cast adrift by the whims of gravity or born into the darkness. The galaxy isn't just a collection of solar systems, it's a graveyard of lost worlds and a highway of lonely travelers, each with a story we're only beginning to uncover. And who knows, the next rogue planet we find might not just be a curiosity, it could be a key to unlocking the universe's best-kept secrets. The saga of Tabby's star is a masterclass in how science navigates the line between wonder and evidence. After the initial frenzy over its bizarre, erratic dimming so extreme it sparked wild speculation about alien megastructures, follow-up observations peeled back the layers of mystery to reveal a far simpler, yet still fascinating explanation: dust. Not ordinary dust, but colossal, uneven clouds of it swirling around the star in a way astronomers had never seen before. What's remarkable isn't just the answer, but how we got there. When the Kepler telescope first flagged KIC 8462852's strange behavior, the data was so unusual that even seasoned scientists hesitated. The dips in brightness weren't just deep, they were chaotic with no predictable pattern. Planets cause clean, symmetrical shadows. Dust clouds usually scatter light evenly. This was neither. It took years of coordinated effort, ground-based telescopes, spectral analysis, even the Hubble Space Telescope, to finally catch the culprit in the act. By studying how the star dimmed at different wavelengths, researchers realized certain colors of light were being blocked more than others, a telltale sign of fine particles. The dust wasn't in a smooth disk but in clumps like cosmic cobwebs drifting in front of a flashlight. But here's where the story gets even richer. The dust hypothesis didn't just solve the puzzle, it opened new ones. Why was the dust so irregular? Why did the star's overall brightness keep fading over years? One theory suggests a cataclysmic collision, like a moon smashing into a planet, leaving behind a debris field that's slowly dispersing. Another proposes that Tabby's star is surrounded by a swarm of giant comets, far larger than anything in our solar system, evaporating as they plunge toward the heat. The real magic of this discovery lies in its humility. Science doesn't always deliver the flashiest answers. Sometimes it trades Dyson spheres for dust clouds, but the process is just as thrilling. Tabby's star became a rallying point for collaborative curiosity, proving that even the wildest hypotheses have value if they push us to look closer. The public's fascination with aliens wasn't a distraction. It was fuel driving researchers to collect more data, refine their tools, and ultimately uncover a truth no one had anticipated. And that's the beauty of accidental science. It's not about being right the first time. It's about staying open to the possibilities, even when they're less glamorous than we'd hoped. Tabby's star didn't give us extraterrestrial engineers, but it did gift us something equally profound, a front-row seat to the universe's endless creativity. Whether it's dust, comets, or something we haven't imagined yet, the cosmos keeps reminding us that the best stories aren't the ones we script. They're the ones we stumble into, eyes wide with wonder. Even the most fundamental truths about our universe sometimes turn out to be riddles in disguise. Take the Hubble constant, the number that tells us how fast the cosmos is expanding. For decades, astronomers assumed pinning down this value would be straightforward. Measure some distances, track some galaxies, do the math. But in recent years, something peculiar emerged. Two precise methods of calculating this cosmic speed limit kept giving different answers. Not just minor discrepancies either, we're talking numbers that disagree by enough to throw our understanding of reality into question. And the wildest part: this crisis in cosmology wasn't uncovered through some grand, coordinated effort. It crept up quietly, noticed by researchers comparing datasets that just refused to line up. The tension stems from two rock-solid techniques that should agree but don't. On one side, there's the local ladder approach, measuring the distances to nearby galaxies using pulsating stars called cepheids, then extending those measurements out to supernova in more distant galaxies. This method gives us a Hubble constant around 73 kilometers per second per megaparsec. But then there's the cosmic microwave background, the afterglow of the Big Bang itself. By studying its subtle fluctuations with satellites like Planck, scientists can extrapolate how fast the universe should be expanding today. That number, roughly 67. A difference of 6 might not sound like much, but in the high-stakes world of cosmology, it's a chasm. At first, researchers assumed someone had made a mistake, a miscalibration, a hidden bias in the data. But as measurements grew more precise, the gap didn't shrink. It held firm, stubborn as a toddler refusing bedtime. That's when the real implications sank in. This isn't an error, it's a clue. The universe might be trying to tell us that our textbooks are missing something monumental, an unseen force, a flaw in Einstein's equations, or even an entirely new ingredient in the cosmic recipe. One tantalizing possibility, dark energy, the mysterious force accelerating the universe's expansion, isn't constant after all. Maybe it's evolving, growing stronger or weaker over time. Alternatively, there could be unknown particles, sterile neutrinos, or other exotic bits of matter skewing the early universe's energy balance. Some theorists have even dared to suggest gravity itself might work differently on cosmic scales, bending the rules we thought were set in stone. What's exhilarating is how this accidental discovery has turned cosmology into a detective story. Every new observation, gravitational waves, quasars, even the distribution of galaxies is now scrutinized for hints that might crack the case. The Hubble tension isn't just a problem to solve, it's a doorway. Behind it could lie answers to questions we haven't even thought to ask yet, and that's the real magic here. Science doesn't progress when everything fits neatly into place. It leaps forward when the numbers don't add up, when the universe throws us a curveball that forces us to rethink, re-examine, and rediscover. So while the Hubble tension might feel like a crisis, it's also a gift, a reminder that even in the vast, seemingly predictable cosmos, there are still whispers of the unknown waiting for us to listen. In 2013, astronomers scanning the heavens with the Very Large Array Radio Telescope in New Mexico stumbled upon something that looked like a celestial Rorschach test, a galaxy spewing out radio waves in a perfect X shape, as if the universe had pressed a cosmic stamp onto the void. This wasn't just a quirk of perspective or a trick of the light. Those symmetrical arms stretching millions of light years into space were the aftermath of a cataclysm so violent it defied conventional explanation. The leading theory, two supermassive black holes had collided, their jets twisted into this bizarre formation like ribbons caught in a cosmic wind. What makes this discovery so extraordinary is how it rewrites the life cycle of galaxies. We've long known that black holes can eject jets of particles at near light speeds, creating twin lobes of radio emission on either side of their host galaxy. But an X shape that suggests something far more dramatic. Picture two galaxies merging, their central black holes spiraling toward each other in a gravitational dance. As they finally unite, the resulting behemoth doesn't just inherit one set of jets, it inherits two, now wildly misaligned. The new black hole's spin axis flips, sending fresh jets plowing through the remnants of the old ones, carving that eerie X into the interstellar medium. But here's where it gets even wilder. Not every black hole merger leaves such a clean signature. The X-shaped galaxy, officially named J0437+2456, might represent a rare snapshot of a transitional phase, a cosmic, before and after, image caught mid-transformation. Most mergers are too messy or too distant for us to see the details. This one, it's like catching a bullet in midair, frozen at the exact moment it pierces its target. The implications ripple outward. If black holes can realign their jets so dramatically, it could explain why some galaxies' radio lobes look warped or uneven. It might even hint at how supermassive black holes grow to such incomprehensible sizes, feasting on mergers like celestial matryoshka dolls. The real magic lies in how easily this discovery could have been missed. The X-shaped galaxy wasn't hiding, it was just overlooked, camouflaged among thousands of other radio sources in sky surveys. It took a sharp-eyed team cross-referencing data to realize they weren't looking at a glitch or an overlap of two galaxies. They were seeing a single object telling two stories, the ghost of Jet's past and the fury of Jet's present, and that's the beauty of cosmic accidents. They don't just show us what we expect, they reveal the processes we didn't even know to look for. Every time we find something like this X in the sky, it's a reminder that the universe isn't just violent, it's artistic, etching its history in forms we're only beginning to decode. So the next time you see a seemingly random shape in an astronomical image, look closer. It might just be the universe's way of leaving its signature, a cosmic autograph written in jets and gravity. The cosmic microwave background, the faint afterglow of the Big Bang, is often called the universe's baby picture, a snapshot of the cosmos just 380,000 years after its fiery birth. But in this pristine image, astronomers found something that shouldn't be there, a chilling anomaly known as the cold spot. Stretching nearly 2 billion light-years across, this region of space is significantly colder than its surroundings, as if someone had pressed an ice-cold fingerprint onto the fabric of reality. At first, researchers dismissed it as a statistical fluke, a cosmic typo in an otherwise uniform sky. Yet as measurements grew more precise, the cold spot stubbornly refused to vanish, leaving scientists with a spine-tingling question: what could possibly leave such a mark? One explanation leans into the realm of science fiction. The cold spot might be a bruise left by a collision with another universe. In the multiverse hypothesis, our cosmos is just one bubble in an infinite froth of universes, each with its own laws of physics. If another bubble had brushed against ours in the distant past, the energy drained from that encounter could have left behind a cosmic cold sore, a relic of something beyond our reality. It's a dizzying idea, proof of parallel universes etched into the sky like graffiti from another dimension. But before we rewrite the textbooks, there's a catch. The multiverse isn't the only suspect. Another theory paints a more mundane but equally mind-bending picture. The cold spot could be a supervoid, an enormous, nearly empty region of space where matter is so sparse that light loses energy as it traverses the void, cooling the cosmic microwave background in its wake. The problem: even the largest known void shouldn't create a chill this profound. That leaves a third, even wilder possibility. The cold spot might be evidence of a cosmic defect, a crack in space-time structure left over from the universe's explosive birth. Like a flaw in a diamond, these defects could warp the fabric of reality in ways we're only beginning to grasp. What's fascinating isn't just the mystery, it's how the cold spot forces us to confront the limits of our knowledge. For decades, cosmology operated under the cosmological principle, the assumption that the universe is broadly uniform at large scales. Yet here's a feature so vast and so strange that it challenges that very foundation. Is the cold spot a statistical outlier, a trick of perspective, or a window into physics beyond our comprehension? Every new observation adds twists to the tale. Some studies suggest the cold spot's temperature patterns don't match a simple void, while others argue its sheer size makes it a 1 in a million fluke. The irony is delicious. We scour the cosmos for answers, and sometimes the universe hands us riddles instead. Whether the cold spot is a multiverse's calling card, a void's echo, or something even stranger, it reminds us that the universe isn't just stranger than we imagine, it's stranger than we can imagine. And sometimes the most profound discoveries aren't the ones that fit neatly into our models. They're the ones that leave us staring at the data, wondering what other secrets are hiding in the cold, dark corners of the cosmos. In 2011, astronomers scanning the cosmos for pulsars, those ultra-dense, spinning stellar corpses stumbled onto something that glittered in the data like a cosmic jewel. Around a pulsar roughly 4,000 light-years away, their instruments detected subtle gravitational tugs betraying the presence of a planet. But this wasn't just another world. Its density, mass, and orbital dance suggested something almost unimaginable. A planet likely made of crystallized carbon, its entire structure compressed into what might be the universe's most extravagant diamond. The discovery hinged on precise timing. Pulsars are nature's most accurate clocks, their beams sweeping past Earth with metronomic regularity. Any wobble in that rhythm hints at unseen companions, and in this case, the wobble pointed to a planet so dense, yet so compact, that only one explanation fit. Carbon, subjected to extreme heat and pressure, like the kind found near a violent pulsar, could crystallize into diamond. Picture a world where mountains aren't made of rock, but of vast, jagged diamond spires, where the very ground beneath your feet would put Earth's most luxurious gemstones to shame. What's wild is how this planet probably formed. The pulsar, named PSRJ 1719-1438, was once part of a binary star system. Its companion, a white dwarf, strayed too close and was devoured, stripped down to its core by the pulsar's gravity. What remained a carbon-rich husk was compressed into a planet-sized diamond, orbiting its ravenous creator every 2 hours. It's the ultimate cosmic alchemy, a star's corpse transformed into a celestial treasure. But here's the twist: this diamond planet isn't just a curiosity. Its existence rewrites the rules of planetary formation. Most planets coalesce from the dusty leftovers of star birth, but this one was forged in destruction, a phoenix of carbon rising from stellar ashes. It raises tantalizing questions. How many other diamond worlds are out there, hiding in the debris of dead stars? Could there be even stranger compositions, planets of sapphire, graphite, or forms of matter we haven't even named? The real beauty of this discovery lies in its sheer improbability. We weren't even looking for diamond planets, we were studying stellar clocks. Yet once again, the universe handed us a surprise, proving that beyond the familiar realms of rock and gas, there are worlds so exotic they defy our wildest dreams. So the next time you gaze at a twinkling star, remember somewhere out there, a planet might be sparkling not with water or life, but with the cold, glittering fire of 1,000,000,000,000,000 carats. Most dying stars paint the cosmos with chaotic swirls of color, billowing clouds of gas that twist and churn like smoke from a wildfire. But in 1973, astronomers aiming telescopes at the constellation Monoceros stumbled upon something that defied all expectations. A nebula so geometrically precise, it looked like a celestial drafting project. The red rectangle, named for its striking crimson hue and near-perfect rectangular shape, wasn't just another stellar farewell. It was a masterpiece of symmetry, a cosmic structure so flawless it seemed almost artificial. At the heart of this enigma lies a binary star system, where two aging stars orbit each other in a delicate dance. As one star shed its outer layers, the gravitational tug of war between the pair sculpted the ejected material into an extraordinary hourglass shape. But here's the twist. Our viewing angle turns that hourglass into the illusion of a rectangle, its edges razor-sharp, its corners unnervingly crisp. Dust and gas, lit by the dying star's glow, create the vivid red hue, while intricate ladder-like rungs of material stretch between the walls, adding a level of detail that still baffles scientists decades later. What makes the red rectangle truly mesmerizing isn't just its appearance, it's the unanswered questions it raises. Why does the dust form those precise rungs, like rungs on a cosmic ladder? How has the structure maintained its symmetry over millennia? resisting the chaotic forces that typically shred nebulae into abstract art. Some theorists suggest magnetic fields are at work, channeling particles into orderly lanes. Others propose the star's unique orbital dynamics act like a pair of sculptors, carving the nebula with gravitational precision. Then there's the mystery of the red rectangle's blue glow, a ghostly ultraviolet halo that shouldn't exist around such cool, aging stars. This unexpected feature hints at complex chemistry, possibly even organic molecules forming in the nebula's shadows. Could this be a cosmic factory for the building blocks of life, hidden in plain sight behind those geometric walls? The red rectangle challenges our assumptions about how stars die. Most end their lives in explosions or sprawling, uneven clouds. But this star chose elegance, crafting a farewell so precise it feels intentional. It's a reminder that the universe isn't just a place of chaos. It's also an artist capable of work so refined, they blur the line between accident and design. And somewhere out there, other geometric wonders might be waiting, their perfect angles hidden until we chance upon them at just the right angle, in just the right light. Galaxies usually come in two flavors: swirling spirals with elegant arms or smooth, football-shaped ellipticals. But in 1950, astronomer Art Hogue pointed his telescope at a faint smudge in the constellation Serpens and found something that looked like it belonged in a cosmic art gallery. There, suspended against the blackness of space, was a perfect ring of blue stars, floating like a celestial halo around a golden core. No spiral arms, no messy debris, just a symmetrical loop of starlight with a bright, detached center. Hogue's object, as it came to be known, wasn't just unusual. It was an enigma wrapped in stardust, defying every model of how galaxies form. What makes this cosmic bull's-eye so baffling is its sheer precision. The ring spans roughly 120,000 light-years, larger than our Milky Way, and glows with young, hot stars, while the core at its center is packed with older, redder stars. Normally, galaxies evolve through collisions or gradual star formation, leaving behind mixed populations of stars, but Hogue's object shows no signs of a violent past. There's no distortion, no debris field, no clue as to how such a perfect ring could emerge. It's as if someone carefully arranged the stars with a pair of cosmic tweezers, leaving no fingerprints behind. Theories abound, each more creative than the last. One suggests a smaller galaxy once plunged straight through the core of Hogue's object, sending shockwaves rippling outward like a stone dropped in water, triggering star formation in a neat, expanding circle. Another posits that the ring is the remnants of a colossal collision billions of years ago, with the debris settling into this improbable symmetry. Then there's the rogue idea that the core and ring aren't even related, that the central galaxy just happens to sit perfectly aligned with a distant ring of stars, creating an illusion of connection. But none of these explanations fully fit. The ring's stars are too orderly, the core too undisturbed. Here's where the mystery deepens. Hogue's object isn't alone. Since its discovery, astronomers have spotted dozens of similar ring galaxies, though none as perfectly symmetrical. Some, like the Cartwheel Galaxy, show clear signs of a violent past, their rings warped and knotted from collisions. Others, like Hogue's, remain pristine, their origins locked in cosmic secrecy. This raises a tantalizing question. Are these rare galactic oddities accidents of chaos? Or is there some undiscovered process that crafts these stellar masterpieces? The real magic of Hogue's object isn't just in its beauty, it's in the way it humbles us. For all our telescopes and supercomputers, nature still holds blueprints we haven't deciphered. This galaxy isn't just a challenge to scientists. It's a reminder that the universe has a flair for the dramatic, crafting wonders that defy our neat categories. So the next time you gaze at the night sky, remember, Out there, beyond the familiar spirals and ellipticals, might be another perfect ring of stars waiting for its moment to step into the light and whisper, "Explain this." Our galaxy, the Milky Way, might seem like a peaceful spiral of stars from afar, but hidden in its depths lies evidence of a violent cosmic feast. In the late 1990s, astronomers studying the motions of stars near the galactic center noticed something peculiar: a group of stars moving in tight, looping orbits that didn't match the rest of the galaxy's rotation. These stars weren't just outliers, they were survivors of a celestial crime scene, the last remnants of a smaller galaxy being torn apart and consumed by our own. This cosmic devouring has a name: the Sagittarius Dwarf Spheroidal Galaxy. Once an independent system, it's now locked in a death spiral around the Milky Way, stretched into luminous streams of stars by our galaxy's immense gravity. Think of it like a spoon swirling honey into tea, except here, the honey is an entire galaxy, and the spoon is the relentless pull of dark matter. Over billions of years, Sagittarius has been unwound, its stars scattered into looping ribbons that wrap around the Milky Way in a ghostly embrace. What's astonishing isn't just the act of galactic cannibalism, it's how we stumbled onto it. Researchers weren't even looking for a devoured galaxy. They were mapping stellar motions when they realized certain stars shared strange, synchronized paths, like a school of fish swimming against the current. Tracing these orbits backward revealed their origin: a dwarf galaxy that had ventured too close to the Milky Way's gravitational jaws. The discovery rewrote our understanding of galactic evolution. Far from growing gently, galaxies like ours build themselves through violent mergers, absorbing smaller neighbors in a slow-motion cosmic buffet. Sagittarius isn't the Milky Way's first victim, just the most recent. Previous collisions have left their own scars, like the Gaia Enceladus galaxy, whose stars now pepper our galactic halo. Even now, the Milky Way is eyeing the Large Magellanic Cloud, another satellite galaxy that may one day meet the same fate. But here's the twist: as brutal as this process sounds, it's also a creative force. The debris from Sagittarius has seeded new star formation, enriching the Milky Way with fresh material. Some of the stars in our night sky might not be native. They could be refugees from a galaxy long gone. And this isn't just our story. Across the universe, galaxies grow by consuming others, their mergers shaping the cosmos into the vast web we see today. The real lesson of Sagittarius isn't about destruction, it's about transformation. Every time we look up at the Milky Way's shimmering band, we're seeing not just a galaxy, but a mosaic of stolen starlight, a testament to the universe's endless cycle of endings and beginnings. And somewhere out there, the next chapter of this cosmic feast is already being written, as gravity weaves another thread into the galaxy's ever-changing tapestry. Sometimes the biggest cosmic breakthroughs happen not in the depths of space, but in a controlled laboratory, and often when scientists aren't even looking for them. That's exactly what unfolded in 2018, when a team at Oxford University fired high-powered lasers at a tiny, hollow plastic tube to study fluid dynamics. Their goal was modest: observe how plasma behaves under extreme conditions. But what they accidentally created was something far more extraordinary: a microscopic version of the shockwaves that rip through dying stars during supernova explosions. The experiment was simple in design but staggering in its implications. By blasting the plastic target with lasers a quadrillion times brighter than sunlight, researchers vaporized the material instantaneously, generating a plasma explosion that expanded outward in a perfect spherical shockwave. As this wave collided with surrounding gas, it did something unexpected. it became unstable, forming delicate, finger-like structures identical to the cosmic filaments seen in actual supernova remnants like the Crab Nebula. For the first time, we could watch in real time and under controlled conditions how turbulence shapes the death throes of massive stars. What makes this accidental discovery so revolutionary is how it solved a decades-old mystery. Astrophysicists had long struggled to explain why supernova shockwaves don't propagate smoothly. Computer models predicted symmetrical explosions, yet telescopic images showed chaotic, knotted debris. The lab experiment revealed why when a shockwave plows through uneven material, instabilities arise naturally, like wrinkles forming in a rug pushed across a floor. These Rayleigh-Taylor instabilities create the intricate webs of gas and dust that make supernova so visually stunning. The real magic lies in the scale. The lab's shockwave lasted mere nanoseconds and spanned millimeters, while a real supernova shock takes centuries to cross light years. Yet the physics was identical, proving that the universe obeys the same rules whether you're studying a star's collapse or a laser's flash. It's a breathtaking example of how cosmic-scale phenomena can be hiding in the smallest experiments if we know how to look. This happy accident didn't just illuminate supernova, it opened a new frontier in laboratory astrophysics. Suddenly, we could test theories about galaxy formation, neutron star collisions, and even black hole jets, all from inside controlled experiments. The universe might be vast, but sometimes its deepest secrets are waiting to be uncovered right here on Earth, in the flicker of a laser pulse and the curiosity to ask, wait, what was that? Mars has never been shy about throwing curveballs, but in 2019, NASA Curiosity rover stumbled onto a mystery that left scientists genuinely stumped. While measuring the thin Martian air over several seasons, the rover's sample analysis at Mars Instrument detected something utterly bizarre: oxygen levels that didn't just fluctuate, but did so in ways that defied every known chemical process on the red planet. Here's what made this so baffling. Mars' atmosphere is 95% carbon dioxide, with trace amounts of nitrogen, argon, and oxygen making up the rest. Scientists expected oxygen levels to rise and fall predictably as CO2 froze and thawed at the poles with the changing seasons, but the data told a different story. During spring and summer, oxygen concentrations spiked by up to 30%, then plummeted back to expected levels in autumn, a pattern as inexplicable as it was consistent. Even stranger, the spikes varied from year to year, as if something unseen was intermittently producing and then absorbing the gas. Theories flew fast and furious. Could underground water be splitting into hydrogen and oxygen, with the hydrogen escaping to space? Unlikely. The amounts were too large, and Mars lacks the liquid water reservoirs to sustain such a process. Maybe solar radiation was breaking apart CO2 molecules, releasing oxygen in bursts. Again, the numbers didn't add up. Even the wild-card explanation, microbial life producing oxygen like Earth's phytoplankton, was a stretch given Mars' harsh radiation and lack of organic material. Then came the real twist. When researchers compared the oxygen mystery to another Martian oddity, the erratic methane spikes Curiosity had detected, they noticed an eerie correlation. Both gases rose and fell in tandem during certain seasons, suggesting a shared, unknown driver. Suddenly, the puzzle grew even larger. Were these gases linked through some hidden geological process? Or was this a chemical pathway we'd never encountered before, unique to Mars' dusty, rusted environment? What's thrilling isn't just the mystery, it's how it exposes the gaps in our planetary playbook. We've modeled Mars' atmosphere for decades, assuming it behaved like a simpler version of Earth's. But these oxygen swings are a reminder that other worlds don't owe us familiar rules. The red planet might be harboring chemistry we've never imagined, with reactions that unfold in ways our textbooks haven't written yet. And that's the beauty of accidental science. Curiosity wasn't even designed to study oxygen anomalies. It was measuring atmospheric composition as a side project. Yet this offhand data might hold clues to one of Mars' most profound secrets. Whether the answer turns out to be geology, chemistry, or something even more extraordinary, one thing's certain: the universe loves to remind us that for every question we solve, there's a stranger one waiting just beneath the surface. In the quiet, frozen reaches of the solar system, far beyond Pluto's icy domain, most telescopes aren't even looking, because who expects to find anything meaningful in that vast, empty darkness? But in 2018, a broken telescope and a snowstorm conspired to prove everyone wrong. Astronomer Scott Shepard, stranded at home during a blizzard, was reviewing old data from the Subaru telescope in Hawaii when he spotted a pixel so faint it barely registered a slow-moving dot drifting against the stars. What should have been a routine recalibration turned into one of the most thrilling accidental discoveries in modern astronomy. Far, far out, a frozen world so distant it makes Pluto feel like a next-door neighbor. At the time, far, far out was the solar system's most distant known object, orbiting more than 100 times farther from the Sun than Earth. To put that in perspective, if Earth were a marble sitting on a sidewalk, far, far out would be a grain of sand nearly 2 football fields away. Its discovery shattered records, but the real magic was in how it was found. The Subaru telescope had been plagued by technical issues that night, forcing scientists to abandon their original targets and improvise. Instead of hunting for distant objects, they'd switched to calibrating the instrument, a task that involved scanning seemingly empty patches of sky. Without that glitch, far, far out might have remained invisible for decades. What's wild is how little we still know about this cosmic recluse. Observations suggest it's likely a lump of ice and rock roughly 300 miles across, small enough to fit inside Texas, yet massive enough to hold its own against the gravitational pull of the Sun from such an extreme distance. Its orbit is a slow, looping path that takes 1,000 years to complete, a sluggish dance in the outer dark. But here's the twist: far, far out isn't just drifting aimlessly. Its trajectory hints at the gravitational whispers of something even bigger, perhaps the long-sought Planet 9, or another unseen giant tugging at the edges of our solar system. The discovery didn't just add another pin to the map of the Kuiper Belt, it rewrote the rules of the game. Before far, far out, astronomers assumed objects that distant would be too faint to detect with current technology. Its existence suggests there could be thousands more lurking in the shadows, each a frozen time capsule from the solar system's birth. Some might even rival Pluto in size, hiding in orbits so vast we've only glimpsed the closest of them. And that's the real beauty of this accident. Far, far out wasn't the target, it was the byproduct of curiosity, of scientists refusing to waste even flawed data. It's a reminder that the universe doesn't reserve its wonders for the well-prepared. Sometimes the most groundbreaking discoveries come from asking, what else is in this blurry corner of the sky? The next record breaker might already be hiding in someone's hard drive, waiting for a stormy day and a sharp-eyed astronomer to bring it into the light. For 60 years, a single diagram haunted solar physicists, a sketch from 1958 predicting how the Sun's magnetic field should spiral outward like a cosmic pinwheel, dragged into shape by the star's rotation. They called it the Parker Spiral, after the astrophysicist Eugene Parker, who first dared to imagine the solar wind's invisible architecture. But without direct evidence, it remained just that, an elegant idea waiting for proof. Then in 2018, NASA Parker Solar Probe did the unthinkable. It plunged closer to the sun than any spacecraft before it, and in the chaos of that fiery descent, it stumbled onto the spiral's ghostly fingerprint. The probe wasn't even hunting for the spiral initially. Its main mission was to solve two enduring mysteries: why the sun's outer atmosphere, the corona, is millions of degrees hotter than its surface, and how the solar wind accelerates to supersonic speeds. But as Parker skimmed just 15 million miles from the sun's surface, 7 times closer than Mercury, its instruments caught something unexpected. The magnetic field lines weren't radiating straight outward as some models suggested. They were twisted, curved, exactly matching the 60-year-old prediction. The spiral wasn't theoretical anymore, it was real, etched into the fabric of space itself. Here's why this accidental confirmation matters. The sun isn't a static magnet, it's a spinning dynamo, rotating every 27 days at its equator. As it turns, its magnetic field gets stretched and wound into this spiral pattern, like syrup drizzled onto a spinning pancake. Solar wind particles, charged and fiery, ride these curving field lines outward, shaping the entire heliosphere, the vast bubble of space dominated by the sun's influence. Without the Parker spiral, we'd struggle to explain everything from the paths of cosmic rays to the quirks of space, whether that knock out satellites. But the real magic lies in how perfectly the probe's data matched the old sketch. Eugene Parker had drawn his spiral based purely on math and intuition, long before spaceflight could test it. To see it materialize in the readings, crisp and undeniable, was like watching a blueprint spring to life. Even more astonishing, the spiral's shape shifted with the sun's rotation, its arms tightening and relaxing like a cosmic slinky, proof that the sun's magnetic personality is far more dynamic than we'd guessed. This discovery didn't just validate a textbook diagram, it revealed the solar system's hidden choreography, the invisible grooves along which energy and particles flow. And it's a reminder that sometimes the boldest ideas, the ones scribbled on napkins or argued over in lecture halls, just need time and the right accident to step out of the shadows and into the light. We tend to think of stars as loyal citizens of their galaxies, born, living, and dying within the swirling arms or dense cores of these cosmic metropolises. But in the late 1990s, the Hubble Space Telescope shattered that assumption with an accidental revelation. Countless stars weren't just drifting within galaxies, they were streaking through the vast, empty voids between them, untethered to any galactic home. These weren't just rogue planets or wayward comets, they were full-fledged suns, some blazing with the heat of youth, others glowing faintly as ancient red giants, all exiled into the intergalactic wilderness. The discovery came while Hubble was studying galaxy clusters, those dense neighborhoods where hundreds of galaxies orbit a common center. As astronomers pored over long exposure images, they noticed something haunting, a faint, uniform haze of light permeating the darkness between the galaxies. At first, they dismissed it as scattered starlight or instrument glare, but when they subtracted the expected light from known sources, the glow remained. This wasn't noise, it was the combined radiance of billions of solitary stars, flung into the abyss by cosmic violence. Here's what likely happened. When galaxies collide a common fate in our dynamic universe, their gravitational tides don't just warp and twist their shapes. They rip stars loose, flinging them outward like sparks from a grinding wheel. Most of these ejected stars don't escape their galaxy's gravity entirely, but in dense clusters where multiple galaxies interact, the combined gravitational chaos can boot stars clear into intergalactic space. Imagine a game of cosmic pinball where stars are the balls and galactic collisions are the flippers. Some stars get launched so hard they never come back. But the real shock wasn't just their existence, it was their numbers. Hubble's data suggested that in some clusters, up to 20% of all stars might live in this intergalactic diaspora. That's trillions of suns wandering the darkness alone. Some could have been exiled billions of years ago, their original galaxies long since merged beyond recognition. Others might be refugees from galactic cannibalism, like the stars we now see in the Milky Way's halo, stolen from smaller galaxies we've consumed. What's mesmerizing is how these stars endure. Without the shelter of a galaxy's dense gas clouds, they'll never form planets or nebulae. Their nights would be pitch black, their skies nearly starless, with only the distant smudges of galaxies breaking the monotony. Yet they burn on, silent witnesses to the universe's turbulent history. Some might even harbor planets frozen, airless worlds orbiting in perpetual exile, their surfaces bathed in the eerie glow of a sun with no neighbors. The most poetic part, these stars aren't truly lost. Their light reaches us, carrying clues about the collisions that banished them. By studying their motions and compositions, we can reconstruct galactic smash-ups that happened billions of years ago, like forensic astronomers piecing together a cosmic crime scene. They're living fossils, their very existence proof that the universe isn't just a collection of galaxies, it's a dynamic, often violent ecosystem, where even stars aren't guaranteed a permanent home. And that's the humbling lesson of these intergalactic wanderers. For all our maps of galaxies and superclusters, the universe still finds ways to surprise us, not just with what's out there, but with what's not where it's supposed to be. Between the grand designs of spiral arms and elliptical giants, there's a hidden population of stellar nomads, reminding us that in the cosmos, even the most fundamental rules have exceptions. So the next time you look up at the night sky, remember, somewhere beyond the Milky Way's glow, there are stars drifting through the void, carrying stories we're only beginning to read. Dark matter has long been considered the invisible scaffolding of the universe, the glue that holds galaxies together with its gravitational pull. Without it, our current models of cosmic structure simply don't add up. That's why the discovery of NGC 1052DF2, a galaxy that appears to defy this fundamental rule, sent shockwaves through the astrophysics community in 2018. Here was a galaxy spinning so leisurely, its visible stars alone could account for all its gravity. No hidden dark matter, no cosmic placeholder, just ordinary starlight where there should have been shadows. This ghostly galaxy, spotted by the Dragonfly telephoto array in New Mexico, wasn't just an outlier, it was a direct challenge to our understanding of how galaxies form. Most galaxies, including our Milky Way, rotate so fast that without the extra gravitational grip of dark matter, their stars would fling into the void like marbles off a merry-go-round. Yet DF2 stars moved with a sluggishness that matched the gravity of their visible mass alone. It was like finding a car speeding down the highway with no engine, a cosmic impossibility under the standard rules. Theories scrambled to explain the anomaly. Could DF2 have been stripped of its dark matter in a violent encounter with another galaxy? Observations revealed no signs of disruption, no trailing debris to suggest a recent collision. Others wondered if dark matter and stars might somehow segregate during galaxy formation, though no known physics supports such a clean divorce, the most tantalizing possibility. DF2 might be evidence of an entirely new class of galaxies, ones born without dark matter altogether, challenging the assumption that it's essential to a galaxy's birth. What makes this discovery so electrifying isn't just the mystery, it's the irony. Dark matter was originally proposed to explain why galaxies didn't behave as expected. Now, its apparent absence in DF2 forces us to ask, What if our expectations were wrong? The universe, it seems, delights in flipping the script. Just when we think we've pinned down the rules, it hands us an exception not to confuse us, but to remind us there's always more to learn. And that's the real lesson of DF2. Whether it's a cosmic fluke or the first of many, its existence proves that even the most bedrock theories must leave room for surprises. After all, the universe isn't just a puzzle to solve, it's a conversation, one where every new discovery has the power to rewrite the questions. Science fiction loves to imagine worlds with twin suns. Luke Skywalker gazing at Tatooine's double sunset is one of cinema's most iconic moments. But in 2011, astronomers combing through Kepler Space Telescope data stumbled onto something that blurred the line between fantasy and reality. Kepler 16b, the first confirmed planet orbiting not one but two stars. This wasn't a Hollywood special effect, it was a real-world circumbinary planet, dancing in the gravitational embrace of a binary star system 200 light-years away. The discovery was accidental. Kepler's primary mission was to spot planets by detecting the telltale dips in starlight when they passed in front of their host stars. But when researchers noticed periodic dimming from Kepler 16 that didn't match a single star's rhythm, they realized they were seeing something far more complex. The light curves revealed two stars eclipsing each other, a larger, cooler orange dwarf and a smaller, dimmer red dwarf, with an additional, subtler dip superimposed. That third wobble, a Saturn-sized planet transiting both stars, tracing a wide, stable orbit around the pair. What's astonishing isn't just the planet's existence, it's how it defied expectations. Binary stars were long considered hostile environments for planet formation. Their competing gravitational tugs should, in theory, shred protoplanetary disks or fling nascent worlds into chaos. Yet Kepler 16b's orbit was remarkably stable, nestled just beyond the star's disruptive influence like a cosmic tightrope walker finding perfect balance. This forced scientists to rethink the rules. Perhaps planets in binary systems form farther out and migrate inward, or maybe their birth disks are more resilient than we thought. Either way, the universe had served notice. Double star systems weren't planetary dead zones, they were uncharted frontiers. The parallels to Tatooine aren't just poetic. From Kepler 16b's surface, assuming it has a solid one beneath its gaseous layers, the sky would be a spectacle unlike anything in our solar system. The two stars would orbit each other every 41 days, sometimes appearing close together as a double-peaked sun, other times drifting apart like celestial dancers. Sunset would be a staggered event, with one star dipping below the horizon before the other, casting ever-changing shadows. But here's the twist: Kepler 16b is far from alone. Since its discovery, astronomers have catalogued dozens of circumbinary planets, some with even wilder configurations. Kepler 453b orbits two stars that eclipse each other every 27 days, while TOI 1338b's stars are so close they nearly touch, creating a continuous ripple of starlight. Each new find expands the menu of possible cosmic environments: planets with triple sunsets, worlds with eternal daylight, even systems where the stars themselves are wildly mismatched in size and color. The real magic of Kepler 16b isn't just that it made sci-fi real, it's how it revealed the universe's boundless creativity. For every rule we think we've decoded about where planets can exist, nature seems to whisper, "Think again." Binary stars, rogue planets, diamond worlds. The cosmos doesn't just tolerate outliers, it thrives on them. And sometimes all it takes is a flicker of unexpected data to remind us that the most fantastical ideas might just be waiting for us in the stars. In late 2019, one of the night sky's most recognizable stars began behaving like a cosmic light bulb on the fritz. Betelgeuse, the fiery red shoulder of the constellation Orion, normally shines as the 10th brightest star visible from Earth, a beacon so reliable ancient civilizations used it to mark seasonal changes. Then, without warning, its brilliance dimmed by nearly 2/3, plunging to its faintest level in over a century of recorded observations. For astronomers, this wasn't just a curiosity, it was a heart-stopping moment. Betelgeuse is a supergiant star teetering on the edge of stellar death, and its sudden nosedive in brightness sparked a tantalizing question. Were we witnessing the prelude to a supernova, the star's final act before exploding in a blaze of glory? The panic wasn't entirely unfounded. Betelgeuse has long been a prime candidate for the next nearby supernova, a cosmic fireworks display that would outshine the full moon for weeks. When stars of its size near the end of their lives, they undergo violent convulsions, their cores fusing heavier elements until they can no longer support their own weight. The resulting collapse triggers a detonation visible across the galaxy. But here's the twist. While telescopes around the world scrambled to monitor Betelgeuse's every flicker, the truth turned out to be far less apocalyptic and far more fascinating. High-resolution images from the European Southern Observatory's Very Large Telescope revealed the culprit, a colossal dust cloud. As Betelgeuse belched out vast plumes of gas, some of the material cooled and condensed into microscopic grains, forming a temporary veil that obscured the star's light from our view. Think of it like a stellar sneeze, a messy, unpredictable eruption that briefly cloaked the star in its own debris. But this wasn't just any dust. The particles were rich in silicon and other heavy elements, the very building blocks of future planets and potentially life. In a poetic twist, Betelgeuse's great dimming offered a front-row seat to the process that seeds the universe with raw materials for new worlds. What makes this accidental discovery so thrilling isn't just the resolution, it's how close we came to misunderstanding it entirely. For months, the astronomical community buzzed with speculation. Some researchers proposed that the dimming signaled a sudden drop in the star's surface temperature. Others wondered if massive convective cells, bubbles of plasma larger than our solar system, had risen to Betelgeuse's surface, temporarily darkening patches of its face. The dust hypothesis only gained traction when telescopes caught the star's southern hemisphere noticeably blotchy, as if smudged by cosmic soot. And here's where the story gets even richer. Betelgeuse's dimming didn't just teach us about dying stars, it revealed how little we know about their final chapters. Conventional models predict supergiants like Betelgeuse shed material gradually as they near explosion. But this event suggested they can cough out enormous clouds in fits and starts with little warning. That means other aging stars might be hiding similar surprises, their farewell performances obscured by self-made shrouds. The real lesson of the Great Dimming isn't just about dust or supernova. It's about the universe's flair for drama. Betelgeuse didn't explode, but for a fleeting moment, it gave us a taste of what that spectacle might look like, and reminded us that even the most familiar stars can still keep secrets. Whether it fades again tomorrow or shines steady for millennia, one thing's certain: when it finally does go supernova, the show will be worth the wait. Until then, every flicker, every hiccup, is a clue, a whisper from a star that knows its time is running out and isn't going quietly. For decades, the moon was considered a bone-dry wasteland, especially in its sun-baked equatorial regions, where daytime temperatures soar to 260 degrees Fahrenheit. Any water, scientists assumed, would have boiled away eons ago, leaving only barren rock. Then in 2020, a modified Boeing 747 carrying NASA Flying Sophia Observatory made a discovery that turned that assumption to dust. As its infrared telescope scanned sunlight reflecting off the moon's southern highlands, it picked up the unmistakable chemical fingerprint of water molecules, not buried in shadowed craters, but right there in broad daylight, clinging to sunlit lunar soil. This wasn't just a scientific surprise, it was a paradox. Water isn't supposed to survive the moon's harsh conditions. Ultraviolet radiation from the sun should break apart water molecules, while the vacuum of space would let any liberated hydrogen escape instantly. Yet SOFIA data was undeniable. The water wasn't pooled in liquid form or even locked in ice crystals. Instead, it was trapped inside microscopic glass beads formed by meteorite impacts or wedged between grains of lunar dust like moisture clinging to a sponge. Each bead acted as a minuscule terrarium, shielding the water from evaporation and solar bombardment. The implications ripple far beyond lunar geology. If water exists in sunlit regions, it might be far more accessible to future explorers than we dreamed. Previous plans focused on mining ice from permanently shadowed polar craters, a costly and complex endeavor. Now, astronauts might extract life-sustaining water or even rocket fuel by processing ordinary surface soil. But here's the real kicker: the moon's water could be constantly replenished. Solar wind, which streams protons from the sun, might react with oxygen in the soil to form new water molecules, creating a slow but steady trickle of cosmic chemistry. What's poetic is how easily this breakthrough could have been missed. SOFIA flight was originally scheduled to study distant galaxies, not our own moon. Only a last-minute change in observation plans directed its gaze closer to home. The discovery rewrites not just our understanding of lunar resources, but the fundamental story of how water, the universal solvent of life, travels and persists across the cosmos. If it can survive on the airless, scorching moon, where else might it be hiding in plain sight? The moon has always been Earth's silent companion, reflecting our world's light but guarding its own secrets. Now we know even its sunlit face holds traces of the very substance that makes our planet alive. And that changes everything, not just for exploration, but for our place in the universe. Water isn't just an earthly luxury, it's a cosmic constant waiting wherever we're bold enough to look. Black holes aren't supposed to get this big. At least, that's what astronomers thought until 2020, when a routine galaxy survey stumbled upon an absolute behemoth, a black hole so colossal it defied every model of how these cosmic monsters grow. Tucked inside the galaxy cluster Able 85, over 700 million light-years away, this gravitational giant weighed in at a staggering 40 billion times the mass of our Sun. To put that in perspective, if our solar system's black hole, Sagittarius A, were the size of a marble, this one would be as wide as the Empire State Building. The discovery wasn't just surprising, it was borderline impossible under current theories. Supermassive black holes typically anchor galaxies, but even the largest known, like the one powering the quasar-ton 618, cap out around 66 billion solar masses. This new contender, dubbed ultramassive, shouldn't have had enough time or material to reach such proportions. Black holes grow by swallowing gas, stars, and even other black holes, but the math suggested this one would have needed to feast non-stop since nearly the dawn of the universe to hit 40 billion suns. Yet there it was, lurking in plain sight, its existence forcing scientists to ask, how did we miss this? The answer lies in its hiding place. Most supermassive black holes betray their presence by blazing brightly as quasars or by flinging stars into frenzied orbits. This one, however, was oddly quiet, a sleeping giant nestled in the heart of a galaxy that had long since burned through its star-forming fuel. Without the telltale glow of infalling matter, it remained invisible until astronomers measured the subtle dance of stars near the galaxy's core. Their breakneck speeds revealed the black hole's gravitational grip, like leaves swirling around an unseen drain. What's truly baffling is how this monster challenges our cosmic timelines. Current models suggest black holes grow gradually, merging over billions of years. But this ultramassive relic appears to have ballooned too fast, like a child outgrowing their clothes overnight. One radical theory proposes it might be a primordial black hole, born unusually massive in the universe's chaotic first moments. Another suggests it gorged on entire galaxies during an era when the cosmos was denser, a cosmic buffet we can barely imagine. The implications ripple far beyond Able 85. If black holes can grow this large, this quickly, they might play a bigger role in shaping the universe than we thought. Their gravity could warp entire galaxy clusters, bending light like a funhouse mirror on a cosmic scale. And if this one slipped under our radar for so long, who's to say there aren't even larger giants lurking in the shadows, rewriting the rules as we speak? This accidental discovery doesn't just add another record breaker to the cosmic ledger. It's a humbling reminder that the universe specializes in building things bigger, stranger, and more inexplicable than our models predict. For every black hole we've charted, there might be a dozen more hiding in the dark, each one a silent challenge to the limits of what we think we know. Sometimes the universe hides its most spectacular shows behind a technical glitch. That's exactly what happened in 2021, when astronomers troubleshooting a malfunctioning radio telescope in Australia stumbled onto something extraordinary, a colossal jet of energy shooting from the heart of two colliding galaxies over 500 million light-years away. The telescope, part of the Australian Square Kilometre Array Pathfinder, was meant to be mapping hydrogen gas in distant galaxies when its receivers suddenly skewed off target. Instead of shutting down the observation, researchers decided to analyze the garbled data and found a cosmic lightning bolt crackling across the void. This wasn't just any jet, stretching over 1 million light-years, 10 times the diameter of our Milky Way. It was the aftermath of a supermassive black hole's feeding frenzy, triggered by the galactic merger. When galaxies collide, their central black holes eventually spiral together, but before they merge, the chaos sends vast amounts of gas and dust plummeting toward them. As one black hole gorged on this sudden buffet, it launched a jet of particles at nearly light speed, visible only in radio wavelengths. The twist, the jet wasn't pointing straight at us as most detected jets do. It was angled sideways like a lighthouse beam sweeping past Earth, which made it invisible to traditional surveys. Only the telescope's malfunction, its misaligned receivers accidentally scanning perpendicular to the jet's axis, caught the faint radio whisper of this cosmic particle cannon. What's wild is how much this accident reshaped our understanding of galactic collisions. Astronomers had assumed jets like this were rare in merging systems, since the turbulent environment should disrupt their formation. Yet here was proof that even amid the chaos of two galaxies smashing together, black holes could still fire off precision beams of energy. The jet's very existence hinted at an unseen order lurking in the mayhem, a magnetic scaffolding that somehow survives the collision, channeling the black hole's fury into a coherent stream. But the real magic lies in what this jet reveals about the universe's hidden rhythms. Merging galaxies are already cosmic powerhouses, birthing new stars and reshaping entire swaths of space. Add a supermassive black hole jet to the mix, and you've got a particle accelerator on a galactic scale, capable of hurling matter across intergalactic distances. Some of these particles might even seed future star formation in entirely unrelated galaxies, like cosmic dandelion fluff carried on a stellar wind. And that's the beauty of accidental discovery. We set out to fix a glitch and ended up witnessing a black hole's roar. a reminder that even malfunctioning tools can become unexpected windows into the universe's grandest spectacles. So the next time a telescope acts up, maybe the universe isn't throwing a wrench in the works. Maybe it's handing us a key. Infrared telescopes scanning the depths of a distant nebula in 2010 weren't hunting for molecular oddities. They were mapping dust clouds, the cosmic nurseries where stars are born. But buried in the data was a spectral signature no one expected. The unmistakable fingerprint of carbon molecules arranged into perfect hollow spheres, like microscopic soccer balls. These weren't just any molecules, they were Buckminsterfullerenes, or buckyballs, nanoscale structures scientists had synthesized in labs for decades, but never dreamed could form naturally in the chaos of space. The discovery was a cosmic curveball. Buckyballs, named after architect Buckminster Fuller for their resemblance to his geodesic domes, consist of 60 carbon atoms linked into a lattice of pentagons and hexagons. On Earth, they're engineered for everything from drug delivery to superconductors, but finding them floating in a nebula that shattered assumptions about how complex chemistry works in the void. Space was supposed to be too sparse, too harsh for such delicate structures to assemble, yet there they were, trillions of them, drifting like celestial confetti in the winds of a dying star. What's wild is how they form. In the lab, creating buckyballs requires precise temperatures and pressures, but in the nebula, scientists theorize, shock waves from stellar winds or supernova provide the energy needed to forge these carbon cages. Imagine a cosmic blacksmith striking carbon atoms with such force they snap into geometric perfection, a natural nanotechnology workshop operating on an interstellar scale. Even more astonishing, some buckyballs appeared to be trapping other molecules inside their hollow cores, like miniature escape pods for cosmic chemistry. This accidental find didn't just add a new molecule to the interstellar catalog, it rewrote the rules of astrochemistry. If buckyballs can form spontaneously, what other complex molecules might be lurking out there? Could space be peppered with carbon onions, nanotubes, or even precursors to life? The discovery hinted that the universe might be a far more sophisticated chemist than we realized, crafting intricate structures in environments we'd written off as too hostile. And here's the kicker, buckyballs are more than just curiosities. Their stability and conductivity make them ideal candidates for carrying complex molecules, perhaps even the building blocks of life, across the galaxy. Some scientists speculate they could have seeded early Earth with organic materials, delivering the ingredients for biology in microscopic armored spheres. The real magic of this discovery lies in its humility. We set out to study dust and stumbled onto a cosmic art gallery filled with molecular masterpieces we didn't know could exist. It's a reminder that the universe doesn't just build stars and planets. It engineers at every scale, from the galactic to the atomic. And sometimes the most extraordinary finds come wrapped in the tiniest packages. Radio telescopes aren't built to find planets. They're designed to catch the faint whispers of dying stars, the static crackle of cosmic events. So when astronomers at the Arecibo Observatory in Puerto Rico tuned into a pulsar called PSRB 1257+12 in the early 90s, they expected nothing more than the usual metronomic blips, the dead star's precise, unchanging heartbeat. But something was off. The pulses weren't arriving with perfect regularity. Some came a fraction of a second early, others slightly late, as if the pulsar itself was wobbling ever so slightly in space. At first, the team assumed it was interference, maybe a glitch in the equipment or a passing cosmic ray. But when the anomalies persisted, they dared to consider the impossible. This dead star wasn't alone. Something invisible was tugging on it with a gentle but persistent grip of gravity. and that something turned out to be the first planets ever discovered beyond our solar system, orbiting not a living sun, but a corpse. What makes this discovery so extraordinary isn't just the planets themselves, it's where they were found. Pulsars are the remnants of supernova explosions, stellar zombies spinning at dizzying speeds and blasting out beams of radiation like cosmic lighthouses. Their environments are the last places anyone expected to find worlds. The violence of a star's death should shred any orbiting bodies to dust, vaporizing them in the blast or flinging them into the void. Yet here were at least 3 planets dubbed Poltergeist, Phobter, and Draugr circling this pulsar in eerie silence. Their existence defied every assumption about where life could take root. The leading theory: these planets might be second-generation worlds, born from the ashes of the star's destruction. When the original star went supernova, the explosion could have left behind a disk of debris, a swirling graveyard of dust and gas that eventually coalesced into new planets. Or perhaps they were once gas giants, their outer layers stripped away by the supernova's fury, leaving behind only their dense, rocky cores. Either way, they're survivors, clinging to existence in a system that by all rights should have been sterile. But here's the real kicker. These pulsar planets aren't just cosmic oddities, they're time capsules. The pulsar's relentless ticks act like the most precise clock in the universe, allowing astronomers to measure the planet's gravitational tugs with astonishing accuracy. Poltergeist and Phobter, the larger two, are locked in a delicate orbital dance, their mutual pulls subtly altering their paths, a phenomenon that helped confirm their existence long before exoplanet hunting became routine. Meanwhile, tiny Draugr, barely twice the mass of Earth's moon, hinted that even the smallest worlds could endure in the most hostile environments. The discovery rewrote the playbook for planet hunters overnight. If planets could form around a pulsar, they could form anywhere. Suddenly, the galaxy seemed wilder, more unpredictable than we'd imagined. And while these particular worlds bathed in lethal radiation, their skies lit by the pulsar's deadly strobe aren't likely to host life. They proved one thing: the universe is far more creative than we are. It doesn't need a cozy star or a Goldilocks zone to build planets. Sometimes all it takes is chaos, time, and the stubborn persistence of matter, and a little static on the radio to remind us we're just beginning to listen. From static noise to interstellar visitors, these 50 accidental discoveries reveal a universe that thrives on the unexpected. Think about it, some of the most pivotal breakthroughs in astronomy didn't come from carefully scripted experiments, but from moments when scientists paused and asked, "Wait, what is that?" A radio telescope picks up a hiss no one can explain, and suddenly we're listening to the echo of the Big Bang. A star flickers strangely, and overnight we're debating alien megastructures. These aren't just lucky breaks, they're reminders that the cosmos refuses to follow our playbook. What's truly astonishing is how often these surprises rewrite the rules. Take dark energy, the force accelerating the universe's expansion. No one set out to find it. Researchers were studying distant supernova, expecting to measure how much the universe's growth was slowing down. Instead, they stumbled onto proof that space itself is tearing apart faster than ever. It's like spending years studying how leaves fall from trees, only to wake up one day and realize the forest is on fire. The universe doesn't just defy expectations, it revels in it. And the best part, this story isn't over. For every mystery we've solved, every cosmic oddity we've catalogued, there are countless others hiding in plain sight. Right now, terabytes of telescope data sit untouched in archives, waiting for someone to notice the anomaly everyone else missed. The next Oumuamua, the next wow signal, could be buried in those numbers, overlooked because no one thought to look for it. That's the thrill of science. The next great discovery might not come from a billion-dollar space mission, but from a grad student poring over old data at 3 a.m., spotting the pattern no one else saw. So here's the real lesson of these 50 accidents. The universe isn't just a puzzle to solve, it's a conversation, one where the best moments come when we're caught off guard. Whether you're a professional astronomer or just someone who loves gazing at the night sky, stay curious, stay open, because the cosmos has a habit of saving its greatest revelations for those willing to embrace the unexpected. Who knows, the next time you look up, you might be the one to notice something no one else has. If you've got a favorite cosmic accident, drop it in the comments below. We'd love to hear which discovery blew your mind. And if you enjoyed this journey through the universe's greatest surprises, don't forget to like and subscribe for more deep dives into the wonders of space. Until next time, keep looking up. The stars have a way of surprising us when we leave.